it's still and anyway interesting for you. So I myself was the founder of a drone company, a co-founder of a drone company, Mavinci, in 2009, and was there responsible for Mavinci desktop development. For those who have not heard about that company and software, we developed our own fixed wing drone, everything from the scratch as it was usual 15-ish years ago. Our own autopilot, our own flight control, a desktop control system for mission or flight planning. We got pretty good in flight planning, and that was one of the major reasons why we got acquired by Intel in 2016. So they were mainly interested in our flight planning capabilities and in our RTK for the drones. And then we basically took this project. I, until then, developed more or less on my own. And basically, the plan was to write a totally new user interface. So we ripped everything apart. First did it externally, didn't went so well. So then we did it again with a team where Jan was also a part from. And yeah, that went until, I would say, beginning of 2020. We had support for the Intel Falcon 8 Plus copter drone. So basically during that Intel time, we extended the capabilities more and more into the copter direction, while we originally started from fixed wing flight planning. Yeah, and in 2020, basically the project was stopped, and we got Intel convinced to donate the entire code base. So what you can already hear from what I'm telling you is that the code base had a lot of major changes, and in its oldest parts, it's kind of 13 years old. So it's a bit of a mess in some places. There are a lot of nice code parts. The problem is it was always stacked on top. And yeah, I think one of the major tasks for the team would be to clean this up. And we have so many interesting things in the pipeline I will talk later about. Especially Jan had some really nice contribution, which hasn't made it yet to the main line. Yeah, but let's get started. I have the Intel original software running on my computer here. I will start sharing my screen so you can see what I see. I'm demoing Intel Mission Control and not Open Mission Control, since Open Mission Control kind of got running the first time yesterday night. And most of, yeah, thank you, Jan, and thank you, Michael Strauss, for last night's effort. The problem is it's some of the resource folders are still missing, so we have to ask Intel for some other files, or basically, or otherwise have to come up with all strings new, all icons new. So please stand by for just a bit more time, then we can go with Open Mission Control. I will also later in the demo switch to Open Mission Control and show you the differences what we added later. So this is the software. It's based on a 3D globe and a JavaFX user interface around it. It's at the moment entirely Windows based, but as I said, JavaFX, so it could also run on Mac and Linux, as Mavinci Desktop was doing in the past. But with Intel, we mainly focused on Windows, so the non-Windows support kind of got removed over time. So this globe here in the middle is an open source project from NASA. It's under nowadays Apache license. It's also, I think, a 20-year-old project. They did really, really cool stuff. Yeah, so let me just zoom somewhere where you have some 3D impression. Yes, it's full 3D, as you would expect. But we did some more cool stuff with this. Let me, for example, zoom to one city of Germany where I imported a data set. Where is it? Oh, there. And this data set was created by our Sirius drones then, and you can see it loading live, but in principle, it's a tiled mesh model georeferenced by KML files. So this is about, I think, 5-ish gigabytes and several 10,000 of files, kind of half a city, I think around 1 square kilometer, where you can zoom through. And all this 3D globe, and I will show you later some more, we basically use for having a good geo visualization. In principle, we can also load GeoTIFF files for imagery reference. Let me see, this should be large. So I have shown you how we can import even complex GeoTIFFs. No, that's the wrong launch. So we can also load GeoTIFF files for elevation support and for imagery support. And I think the GeoTIFFs I have loaded here, they're only 2.5D, so buildings look a bit shady. But also here we have an entire city in a resolution of, I think, 5 centimeters loaded hierarchically, so it's still really fast. We can import also, let's say, single objects, like, where's my favorite one? This data set we created with Falcon drone, and it's basically adding a 3D bridge into the normal landscape. So if I'm disabling it, so you see this is kind of what you get vanilla, and we could add some object like that. Beside this, we can import KML, GeoTIFF files. We have WMS server support, so you can connect to kind of every imagery server on the world. We have airspaces included based on AirMap if you have a license key. We have at the moment Mapbox background layers if you have a license key. And yeah, we can also do something like contour lines and whatever. So it's quite nice map background. You can also do your entire coordinate system planning in whatever coordinate system you prefer. So there's an EPSG database in the background. So it's very prepared for being a full geospatial software. But let's start with some real projects. I have something prepared here for you. Here's a list of recent projects. Let's go with that one. And there's a flight plan I created. That's boring. Let me create a new one. So my favorite example is the city of Heidelberg, because I'm living very close by. So if you want to do flight planning, which is a major feature of the software, typical workflow is you selecting a drone. At the moment, we have only the Intel drones in this release, but in the upcoming one, we have also description, I think, for all DJI drones. Let's go with a certain drone and let's start planning. So it asks you for what kind of mission structure behavior you want to have. So there are, let's say, 2-dimensional types and 3-dimensional types. Let's start with a polygon. So if I just clicking the polygon here, I think that's what everyone knows. If I can edit it afterwards, and it generates you some flight lines. Each flight line has here a line pointing to the ground, showing you the direction of the camera. So we are supporting drones which can adjust camera orientation, like copters, and we're also supporting drones like fixed wings, which are not so flexible in adjusting heights or in adjusting camera directions. So in principle, in this hardware description I just showed you, you can, it's an JSON format, or XML format, I don't remember in detail, where you can specify what is your drone and your camera and your lens and whatever capable of. And you get flight plans like this. So you can edit this, you can add corners and whatever. Okay, but what happens if this flight plan is, let's say, in the side of a hill? So we selected a copter drone, and what he's doing, he's adjusting the camera orientation to tilt it against the terrain. That's the moment. Let me remove a couple of flight lines. Let's make it way smaller, then should be way better visible. So as you can see, it's always pointing perpendicular to the terrain, and the distance of the image triggers on the terrain is equally distant, but not in the air. So you get a perfect overlap. So everything is optimized for getting really, really good photogrammetric results. Speaking of which, you may have seen that we're doing this greenish color coding here on the terrain. So what's that? If I hover with my mouse over it, you can see the small tooltip, pre-flight estimation, 14 images overlap, 10, 10. So we're basically projecting each and every image to the ground and estimating the overlap we would get at that spot of the terrain. Here, for example, you get only 5 images, which is normally still good enough, but the problem is you get 5 images from one flight line, since the center flight line is not reaching far enough to the outside. So we're estimating this as bad quality. Here at the top border, you see something like 1 image, so he can give you estimations. So the polygon we used for planning here in the center has, should be somewhere here.
By the way, Marco, would you prefer questions while you're going along or at the end?
I'm open for questions. Please go ahead.
Okay. I was curious earlier what makes up a drone description when you had that list of drone descriptions, and Paul had a question in the chat about whether this particular drone that you're using tilt the camera to point it perpendicular to the terrain.
So let's start with the drone description ones. Let me just show you drone description.
Okay. I was partly curious as to whether it's something we could pull out of the RGPilot parameters, or whether it's like a JSON file that people would create for their vehicle. Is there some sort of editor for these descriptions?
So first of all, do you have a hint for me? How can I hide this Zoom title bar? Or is it going away on its own? Jan, did you remember where the hardware descriptions are placed? Otherwise,
I'll also have a look.
I found the original ones, resources. I found the original.
There's Intel Mission Control source main Java.com, Intel Mission Control hardware, and then there's all the Java files for those descriptions.
There it is.
Yeah, at the moment, I think so. Let's say the description folder is one of those which is missing at the moment, which Intel forgot to donate. Let's start with, I don't know, the Intel Falcon 8 Plus description. So you have something like, okay, name, ID, some legacy like how to connect to that, what image should he use. But here it gets interesting. Maximum line of sight in meters, plane speed max, so how fast can you fly? Do you need a certain overshoot at the end of line, or is the drone overshooting lines? How early does it start to turn? So do you have to extend flight lines or not? Angular speed noise, so is there a certain rotation noise on the drone we have to compensate for? Maximum angular speed, so you see there's a lot of numbers. Is fixed wing, is copter? Then you have like, how is the payload mounted relative to the drone? What are the compatible cameras for these drones? And then in the cameras, again, we have a list of lenses. Principle, it should be very extensible, and this is how it is at the moment.
Yeah, that looks really quite detailed.
Yeah, and yeah, we, as I said, we use it for a lot of automatic flight planning. Here you can see what axes are fixed on the camera. So what is the gimbal enabled to rotate and what is the gimbal not enabled to rotate? What are the maximum gimbal angles? Is there a certain offset in something? What is typical exposure time? You name it, there's plenty of stuff in there.
So the resulting flight plan then presumably would include the desired pointing angle or is it a region of interest, like a ground point region of interest? Or
so let's export the flight plan. Yeah. Let me. Okay, sorry. This version is not. But okay, we can do it this way. Okay, here's a list of generated waypoints out of this computation.
I see it.
You can
got
see
the
for
camera
each
angles.
image, you get latitude, longitude, altitude, above reference point, about takeoff, above ground. What speed should you have at that point? How long you should hover there? 0 means just fly through. The camera orientation, and should you take an image or not?
Right. Yep.
You can see there are even some additional points added for getting the turns right. Yeah, you can have a random text at those points.
Yeah. So so it'd be interesting to see how we can fit that into the mission structure that we have at the moment. Because we'll probably need some additional mission items which contain the camera data. Most of the rest, the heights and things, that's all just part of our standard mission now, and the hover time is part of standard mission. The desired flight speed being part of the mission is different from how we do things at the moment. But we could have like a meta waypoint. I'm just sort of thinking out loud at the moment. Randy may well chime in.
Basically, what we do, before I continue, do you have a hint for me? How can I hide this toolbar?
Well, we don't see the toolbar up the top, so it doesn't worry us.
I got it. Okay, anyway. Yeah, so
just a question,
Sure.
Tridge, why is that camera stuff a problem? We can control the mounts, pitch and roll in your
but synchronized with the waypoint. So it's basically saying it wants the camera to be at this angle at this waypoint. It wants to be doing that speed at that waypoint. I'm not quite sure how we synchronize that in our mission. Because the mount takes time to turn. So do you sort of set it at the start of the previous leg, or I'm just
as soon as we execute all do commands, which is a do command, as soon as you exit a waypoint, it'll move it to the new position, which may or may not be what you want.
Yeah, it might not be. You might have to have some intermediate ones because your shutter could still be going from the previous photo.
Yeah, so maybe I think we can do there something. And also, basically, the software was built to be very, very flexible on a lot of those. For example, with the Sirius drone, so with the fixed wing, the logic on the drone was you just say like, okay, I need images in at least this distance and at most that distance, starting from here to there. So you gave certain degrees of freedom to the drone, and we just did a, let's say, worst case estimation on the desktop software. And the background for this was you just saying, here's a window of opportunity, take a picture whenever you're ready and whenever you are steady. So don't, like, if you're in the full swing by, maybe wait a half a second before you get a motion blur picture.
Yep, makes sense. Yeah, sorry, please go on. I was just sort of thinking through how we'd adapt this into the ArduPilot world.
So as you maybe have seen before, we have a lot of, let's say, geometric primitives, but we'll basically just go through the main idea. So for each flight plan, you get here a summary, like what is the time to flight, what is the flight distance, images, and you see you can edit the images. You can make mass editing, like, I don't know, you can filter for things and say, okay, I want to all selected points, I want to add something. You can do really fancy stuff with that. You can like invert the selection. There's like select waypoints with warnings. I will show you what warning means before and things like that. It's a very, very manual way of editing, but yes, it's also there if you really, really want to do that. Basically, let me do something. I will just delete a certain point. So what we see now in the lower corner, there's a warning. Ooh, why is there a warning? Let's click there. Or will not get full true auto coverage, estimated only 80.8%. You see the true auto coverage. That is basically the amount of the polygon we specified as the goal area, which is green. And here in the lower bottom, I think there's some percentage which is not perfectly dark green, but pseudo auto quality, yeah, it's 100% because everything from the polygon is covered. And additionally, we also get the area. But back to the warning, it just tells me, yeah, it's not perfect. And there's a second warning, flight lanes not computed automatically. You want to enable it. So there's interactive warning with fix me option. So if I click on it, it's fixed. And yeah, if you now go back to the menu, it's back to automatically computing things. And the warning I just showed you is just one of those. Like, yes, do you want to compute waypoints automatically, flight behavior, follow terrain surface, or just fly straight? If you're flying straight, yeah, you're flying straight into the mountain. That's maybe not that nice. And you see, oh, there's a lot of more warnings. Minimum altitude is minus 55 meters. It's too close to the ground. Your minimum distance, it's a parameter of the drone, is at 3 meters. And then there's a resolution difference. Like, yeah, the minimum and maximum resolution is more than 30% difference from what it should. Obviously, because we're coming very close to the ground. So you can change the flight behavior or can say like, I don't care. You change the flight behavior, everything is good again. Ground speed, we can make it automatic. We can make it, what is automatic fixed? I don't remember. You can set it manually. So let's our drone fly really, really fast. Oh, it's only 10 meters. Selected overlap is beyond capabilities at the speed. So the problem that's 80, probably is 0.something% more here. So he's even warning you like, okay, I'm flying so fast, my camera can't trigger fast enough. It will go wrong. So you will get a bad result in the end. And again, he suggests you like either go slower or just accept it. And if I say go slower, my speed is not 10 meters, but 9.8 meters a second. Unfortunately, I can't entirely break it since the limit here for this drone is 10, but we can do something else. We can say, the resolution should not be 1.3 centimeter, it should be 0.5. And you get a new flight ground distance, you get way more waypoints. The speed is probably way too fast for the drone. Yeah, at this speed, the camera can only do 56% overlap. So either fly slower or accept the overlap. Then we have a very detailed height concept. So all drones I saw so far, and probably you're way smarter than me at this, drones are referencing all the internal heights to wherever they're switched on, and this is 0 height, and then everything is referenced to that point. That's what we saw most. And you can now put here a takeoff location, like, okay, this is the spot where I want to take off. And then all heights are referenced to that point in the export. Internally, we're computing in global altitudes. But for whatever we're writing out to the drone, we can say like, okay, everything should be referenced to that spot. And if you connect the drone to the software, it will automatically adjust it at the moment when you transmit the flight plan. But since we also can, let's say, create flight plans ahead of time, export it to SD drive, and we can't check it. Yeah, so there's takeoff position, hardware, I already told you, but it's entire, what else? So we have for the polygon here, a lot of additional properties. As I said here, minimum is like resolution and distance, which are coupled to each other. If you're changing one, the other one is changing accordingly. And for the polygon itself, we have a lot of settings like overlap, in-flight direction, parallel to flight direction, order of waypoints, where when you start flying. Typically, there's some auto magics here, but you can also force it to certain things. You can change the direction, like best suited for terrain, then he will just fly as most up and down as he can, at least for a copter. For a fixed wing, it would be just flying as constant heights as you can. So he already knows what kind of plane you have, and then adjust the flight direction accordingly if you want. Like this would be a more fixed wing-like flight plan for the same. You can add some camera pitch, like if you, for whatever reason, want to have your camera pointing some degrees forward, you can do that. You can just do additional orientation or adding to the mouse outer lines that you can always get shoots into the polygons. You can just say, please toggle my camera. 1 second. I think it's hard to see. Let me change something. So this settings basically means please alternating adding plus and minus 45 degrees, which could be really good for getting really awesome 3D models, including all the textures and facades and whatever. So basically the gimbal goes the entire time back and forth, and things like that. You can do that also with the rotation of the cameras. We can have default values for all of this. You can make your own default values. You have a lot of ways to setting up your own structure on this. So this was just polygons. A typical flight plan can contain more than one area of interest. Where is it? Add area of interest. So let's, I don't know, adding a square spiral. So now you have like 2 area of interest types, square spiral. I think the name is self-telling. I think you're often using that kind of pattern in search and rescue, starting at the center and just flying spirals until the battery is empty, recharging and then continue flying outwards. And you can have multiple of those in one flight plan. So now we're getting even more warnings. Line of sight is too long for this type of drone and things like that. Everything what is red here, let's hover over it, is too high over ground. Here's a class E airspace where you're only allowed to fly in that area 99 meters over ground or less. So he's highlighting that in red. So he's doing a lot of background checks all the time. And it's also quite extensible. And as you see, it's all those checks and warnings are kind of calculated not in time, but let's say with half a second delay. So it's not slowing down your software while you're using it, but it gives you an update of whatever you have in front of you kind of instantaneously, which is a nice balance between performance and, let's go here on the other side of the valley, performance and getting real-time insights in what you're doing here. Okay, let's do a new flight plan. As I said, we have here, what else do we have? City grid. Let's do that as the last one. And I think I saw the city grid feature on your base latest mission planner announcement. So basically it's just flying 2 grids in 90 degrees rotation relatively to each other. And if you combining this with adding some tilt to your camera, you're getting really good facade imagery. Yeah, that's kind of what it's good for. And that's also kind of the way how we did cities. Okay, so this was more the fixed wing-like stuff. Unfortunately, I have no fixed wing drone in the software at the moment, but let's go for the more drone-ish things. So let's start with a simple tower. You're giving a center, you're giving a radius, you're giving a height of the tower, and telling him what resolution do you need at the tower surface. Let's go with something incredible small, and then he's adding as much as you need, photos, flight lines, and whatever. And also here you have thousands of more parameters you can adjust, like what is the flight pattern, what is the rotation, minimum maximum distance, and so on. He's also taking into account that you can't go as close as you like to the ground. So the lower part of the tower is we're doing as good as we can to still cover it. So we just, if we are at minimum flight altitude, we go tilting camera down and going closer to the tower. So we got kind of comparable results. Also here you see some warnings. This is too close to the tower, which is obviously the case. So it's not conflict-free planning. So you can give in values which make no sense, but he's still computing it for you, but at least he warns you. Next step would be that he's even avoiding stupid things entirely on its own. Partly he's doing that, but not entirely. So tower. Let's go for the next one. Building, which is basically a polygon, and he's just going around that polygon. Yeah, so basically has a polygon to cover the rooftop. He is going around the facades, always taking care he's having perfect overlap at the facade and not equidistance of the drone flight lines. So the drone flight lines get different distances, let's say outside, especially for corners. We're making sure that photogrammetry is not breaking. There's typically a constraint of about 15 degrees between different flight lines. So 15 degrees, yaw differences at different flight lines. So photogrammetry is not breaking. You can for sure adjust this as well. So there's facade, which is basically, yeah, like the building, but yeah, just one wall, or if you like, you can also get multiple walls with corners and whatever. We also have under the hood something like a fully parameterized 3D windmill. So you can enter the blade length, you can enter the hub diameter, the tower height, the orientation, and he's doing an inspection flight pattern around that. So there's a lot of those things, and maybe now is a good spot to highlight what Jan was doing, but it's not integrated yet. In the next version, you can, so we have the code yet, but it's not integrated in the user interface. Just load any arbitrary mesh or 3D structure with undercuts however you like a bridge, like a windmill, like a, I don't know, big, expensive object you want to inspect. I don't want to name things. And just crop out a certain section and tell it, like, please cover it with that resolution. And he's computing perfect flight lines and minimum, yeah, with no collision, with perfect overlap at the object, with all the photogrammetric constraints. That won't be that instantaneously, but Jan, do you want to tell more about that?
Yeah, basically it does exactly what you said. You load in some kind of mesh, I think an OBJ mesh, and it would just basically cut up the whole object into flight line layers, and then it will just fly around it, and taking into account that you want to have the same coverage at every point on the object. And you know, it also supports a little bit of the weird shapes, like if you have a bridge or so, then it will normally fly around every pillar of the bridge. That's basically it.
Mm-hmm. Yeah, I'm really curious if we get that integrated. We kind of playing with that kind of technology for the last, I don't know, 5-ish years. I think 2016 I first started a bit of that, but Jan really made it way better. We even did a keynote about that. So if you look for AUVSI 2017, I think it was 2017, we demoed kind of that on the big stage. You can find that on YouTube. Okay, so this is flight planning. As I said, there's a lot of warnings we do in the background, like estimating speed of camera, motion blur, overlap with airspace restriction zones, with terrain, maximum line of sight. I don't know, I think it's 30 different checks we're running entirely all the time in the background. And for most of the checks, we're even simulating the entire trajectory and deriving the checks based on that. Okay, so next step would be normally that you, after planning, you throw out your drone and fly. I will show you that in a second, because it's not part of Intel Mission Control in the released form, but it will be part of Open Mission Control. Let's first go to what you do after the flights. After the flight, you have a data set. And I will show you a bit of what we have here. So basically, after the flight, you can typically have either a set of images with proper EXIF metadata with orientation and latitude, longitude, and everything inside. Or after the flight, you have one folder with images and a log file, and you have to bring that together. We basically supporting both.
How do you time synchronize between a log file and the images?
Sorry, can you repeat that?
How do you time synchronize between the log file and the images? Because very often there's a bit of a time skew between the two.
Yeah. So basically we have an estimation algorithm, because next problem is like you have a time offset. You have some stretching in time, maybe a bit.
You have drift with slightly different clock rates.
Yeah, and you have very often like losing images, like you think you triggered an image, but you have not. Or sometimes there's an additional image because someone put it on the SD card because he thought it was part of it. So even the amount of images doesn't match. And also typically in the Exp metadata, you have only integer seconds. And on your log files, you have, I don't know, microseconds, nanoseconds, whatever. So this is all the problems we also encounter. And we basically have an algorithm which kind of tries to find a perfect matching between them, minimizing the time jitter in the offset. And
it's doing that by examining the images themselves. So it's trying to do the matching of the images itself. Right. Okay.
Yeah. And it works for most of the time very well. But let's say in 1% of the time, or corner cases, if something is somewhere broken, it's computing forever and not coming up with any result. So it's not perfect yet, but I know that within our drone team, it was a hell of a relief after we basically brought in that to the team by the Mavinci acquisition, because everything they had before was way more bad to use. So it's already very smart dealing with missing images on I don't know, a couple of % of the amount, dealing with too many images. Basically, we even calibrating different cameras, because we saw some cameras have a behavior that they're kind of buffering images, and due to the buffering, they're using the timestamp not at the trigger point, but at the writing point, and then you have a buffering jitter as well, and that gets really messy.
Yep, nasty.
Nasty. So, okay, for whatever reason, this is not showing you what I wanted it to show. Let me restart. I think we just encountered a problem. So basically next would be, as I said, matching images with the drive. So you either importing SD card with already metadata inside, or you just telling him, okay, here's the log files, maybe multiple, here's the images, please do your magic. And then it copies over data, maybe downloads it even kind of on the fly from the drone if it's necessary. Okay, let's go back to the data sets. Okay, so basically every red triangle here is image position. So now I am a bit bad luck, because for whatever reason, he's not showing me the ground preview. Okay, this is the demo effect. It worked yesterday. So normally what you should see is that, like this. So, right, so you're getting in the background all images projected on the ground in a really, really low resolution, which helps you to see like, okay, have I actually flown the area I should fly? Sometimes you get from your customers like, map, please fly that polygon, please fly this building, then you, or let's say this construction site, and you look on Google Map where that is, plan your flight, but actually the construction maybe have moved. They're now building 2 weeks later somewhere else. So it's good after the flight to have a quick check to see, oh crap, I wanted to capture this island here, but the island is at the corner, so I have to do some additional images. You should see that before you go home, and having this quick preview really helps with that. You can zoom in, and the most center image he's giving you in full resolution, so you don't even have to. The problem is the full resolution loads a couple of seconds per image, so you don't even have to open it externally in enemy image viewer. what you still could do with the right click. He's just showing you the images most under your cursor. So you can do that kind of stuff. What else can you do? You can also, for other kind of lights, you can't project it to the ground. Let's say if you fly around a tower, you can just show individual images hovering in the air. And yeah, for a keynote, we already integrated it, but one of the next features is you would click, if you click an image, he zooms in and makes it a 2D preview in full resolution, kind of seamlessly in the 3D view.
This projection you're doing now, the matching to global coordinates, is that being done solely from the data from the autopilot, or is that being done using the image data to match up against, for example, Google Earth or similar?
No,
where's the
it's purely metadata, and for that reason it just takes you 1 second or 2 seconds. So this preview is incredibly fast.
And that's why there's some errors as well.
Yeah, sure. But it's the question is, how good is good enough? If you want to get a better preview, if you see, if I now have enabled filters based on a polygon, if I move my mouse around, you see the background computes kind of, let's say, half a second, quarter of a second. So this is the amount of time we need for computing such a stitching. And it only works because we just entirely rely on the metadata.
Right, yeah. Now, can you adjust, I mean, height information is often a bit off, depending if they've had a, RTK fix. Is there a way you can sort of do a global height adjustment or any other sort of global adjustments for errors?
Well, now it's 100 meters higher.
Okay, yep.
But we are already, also here we're doing some tricks in the background. We kind of averaging over the entire flight plan. You typically have a barometric height and a GPS height, and we try to compensate them against each other and try to find out, so what is the height at your takeoff point? Try to match that with Google Maps or with whatever map we have, and then automatically adjust certain global offsets.
So with the matching against the takeoff point, the problem is that you might be on some structure. I mean, Google Earth doesn't, its DEM is not great.
That is the reason why you can adjust it. But let's say this automatic add-on offset estimation works quite well for, let's say, something like for whatever you mixed up ellipsoidal heights and geodal heights and things like that.
Yeah. Can you choose which geoid it's using?
Yep. As I said in the beginning, you can go here.
Right. Okay. Great.
Through tens of thousands of coordinate systems.
Yeah.
I'm not sure. I think in the end we had somewhere code where you can even load like really geoids, like local geoids with high resolution. The problem is with those, as far as I know, there's not a really good standard file format for it. So we are, that's an open thing. And if you're going really in surveying, a lot of people asked for that, but it's a special corner case, but some specialists are really crying for that. But I think at the end, it doesn't really matter for flight planning. You have to get it right in photogrammetry and processing. But here it's fine if you're off by a meter, if you're flying on 100-meter heights or on 50-meter heights.
Oh, it's mostly sort of WGS84 versus, AMSL sort of thing. That's the most common. I mean, the typical like U-Blocks GPS can provide both, and then RGPilot's got to pick which one it's going to be based around. So we just got to make sure that that default, matches up with what OMC does.
Yeah, sure. So here afterwards, you can even get some statistics, and also here you have warnings like, oh, auto coverage is not perfect, which is true since I modified the polygon way beyond its original mission area. You can get the coverage, he can tell you how many images are passing your filter. You can even do manually filtering like, okay, altitude is currently between 38 and 41 meters, but I don't know, do a filter on 40 meters plus minus 1 meter, then he's removing even more images. So you can filter if you really want to. And at the end, you can export it to a couple of softwares like CSV, metadata writing back. We have integrated, let me show you, where is it? So we've integrated Metashape, context capture, and Pix4D. We even integrated some automatic upload for Intel processing services, which I guess got deprecated over time. But in principle, you can upload it to Intel Geospatial. For Argisoft Metashape, we even have our own Python plugin within Argisoft Metashape, where we're doing a lot of RTK optimization through running through the dataset a couple of times, doing filterings to really tweak the accuracy. That was one of the tricks we did with Sirius in the past, how we tweaked the RTK accuracy by just doing very smart filtering within Photoscan. And even that Python script and plugin will get released, but at the moment, they're not compatible with the newest version of Metashape, but I guess it's just a couple of hours fixing as soon as we have time for that. Yeah, so much about data sets. You can merge multiple data sets. You can process a lot of them at once. I think okay, somewhere there we stopped doing the work, but in principle, it's at least there was some planning for doing that. It was capable with DaVinci Desktop beforehand. Yeah, next, what I would like to show you is Open Mission Control and what we do for muffling. Before that, any question about flight planning or data sets?
Oh, hi, Marco.
Hi.
In the beginning, you showed some profiles with constraints regarding the camera and some things about the aircraft. Yes. Do you have any kind of constraints regarding the flight endurance? How to break a flight plane to merge two flight planes or split in two flights or battery endurance stuff?
So we, at the moment, there's just like max, it's part of the drone description, max flight time. So you can't find it right now. Somewhere here should be maximum flight time. Okay. And we are only warning if it gets too long. We had a lot of wireframes drawn how to automatically split it up and what to do there, but that's not yet integrated. So there's also no coding around it. We had something like that before from DaVinci Desktop, especially for, let's say, big fixed wing flight plans, large polygons. And what we learned there is if you're splitting it up before you actually go to the field, it's actually a stupid idea. So our planning was more into a direction, we called it agile flight planning or something like that. So you're planning a big polygon and just making, let's say, a preliminary breakup with some estimation and doing it slightly too large for a single battery. Then you're doing your first flight, then you basically got the log files in, see what you actually covered, and then the remaining flights are newly computed based on what's left over and not on your last planning. So after each flight, you replan because what we saw, like if you go to the real world, either you're planning with a lot of buffer, then it takes you way too long, or you're planning without buffer, and then you very often can't do the flights because you plan to have a takeoff location there, and then there's a tree in your way, you have no line of sight, or there's some water. And so this planning ahead of time without being there was very often, you have to be so conservative that it's actually possible. And so we did it that way. And our plans for redoing it was, yeah, we call it agile flight planning. So we have all the concepts in our mind, but not yet coded.
No, sure. Just about, because I was wondering about the cylinder that you showed that you can map. No, you take photos against an structure. So it's almost everything is so close. You just need to go around, go down, change the battery and stuff like that. Okay.
Yeah, but let's say how we did it at Intel is like we exported a really large flight plan to the drone, and then the pilot paused that flight plan swap batteries and continue that flight plan. So from Intel mission control perspective, it was just one. In real world, it was several.
Okay.
But you could.
Okay, no, sure. Thank you.
You're welcome. So I have 10 minutes left, so let me start up open mission control.
The timing isn't strict, by the way, so if you go a bit over, that's absolutely fine.
Okay. Why is it not starting up?
You need to close IMC before you
right.
can. Yeah.
Right. Yeah, it checks if it's already running and then. Okay. So what we did yesterday is getting a lot of old, let's say, public available libraries back into the repository, so it's somehow starting. What's still missing is a resource folder with all strings and all icons and whatever, but we will get there. So let's start a random, by the way, random flight plan. So you see here, there's now geofencing included, way more artwork we did. We have different operation levels in the software. Maybe let me do that quickly. Yay, Overlord. Let me be Overlord. Let's do a new mission. That's okay. First of all, you see there's a lot of DJIs in here, Intel drones, Sirius, the Mavinci drones. And I think we even played with unique drones. So where's the windmill? Anyway, let's go with the polygon. No, yeah, also see that if you're doing a too large polygon, he warns you like, it's too large, I won't do a flight plan. Anyway, what I really wanted to show you is we have not only the planning button, not only the dataset button, but something in between. We are calling the flight tab. Since I have no drone available here, let me connect to a mocked drone. Yeah, it's still 3D, but the drone is somehow hovering in the air. So we have something like a dashboard with the most important parameters. On some of them, you can click to get a chart. This thing's starting to shine orange or even blinking red if they got on certain warning ranges. All those warning ranges you can define on the drone level and the specification files. You can select emissions. You can have automatically and manual pre-flight checks. All these warnings and fix me concept you saw from the flight planning, we also encountered in the flight execution tab. In the flight planning, you can use your drone as your GPS, like please put the center of the drone, of the tower, 5 meters in front of the current drone location. So you can do something like that. If you're out there in the field, want to do your planning and you have no good map, you can just use your drone for georeferencing whatever you're planning. And yeah, unfortunately, I can't show you a lot because I have no muffling simulation running here. So we tested it already with PX4, I think several different drones, including our own. We tested this with some other pilot drones. I wouldn't say it's perfect, but it's good enough. We also have live video support in here. You can get something like a preview of the video collection in the lower corner based on, Jan, what was it? Do you remember what library? What Anton was doing it? Oh, never mind. Yeah, you can have manual pre-flight checklists, which are specific for different drones. So what should you do for this drone to actually take off? Automatically check results failed. Yeah, there's no drone available. Yeah, there's the visualization here. You can do something like stay on the drone, centered, have the perspective out of the cockpit of the drone. You can switch the map from 2D to 3D. Do a lot of nice things. You can measure on the map. Yeah, and is there? Fuck, I thought we should be. So in principle, there's also something like Windmill flight planning. It's way more primitives here. You can add no-fly zones manually if they're not coming from your data provider like AirMap. You can even manually include them. He's not automatically avoiding them in planning, but at least he warns you. The next step would be automatically avoiding flying into the no-fly zone. And then if he has to maybe shoot into the no-fly zone from the outside, that was all on the next list. And yeah, so coding wise for us next would be getting the remaining files, getting it running from IntelliJ as the first thing, and then next getting a command line version compiling so you get an installer can actually run the software. And if we have, let's say, a software you can just install without a development environment around it, if that is achieved, then we're super, super open to clean up and to feature improvements and to whatever. But I think that should happen first. Getting it usable
completely
for
agree.
everyone.
Yeah, you get it building, get it in CI as well, so that it can build.
Right. Thank you.
GitHub Actions is our preferred CI. We also use Semaphore, but generally we're moving most things to GitHub Actions, and so getting sort of every commit and branch and PR and things. And at least some, preferably with some testing, but even just getting it to build in CI would be a great step. But you know, testing, automatic testing would be lovely as well. But it's difficult with a UI-based system like this. It's somewhat of a challenge. And then you know, connecting it into ArduPilot software in the loop simulation, that would be really valuable, because that would allow people in the community to try it. And the question is sort of which SITL we should use. We've got lots of different physics backends that ArduPilot supports. The ideal one would be like an immersive 3D one, which gives you an open world so you can actually simulate at the location you are on the planet. But such a one doesn't actually exist as far as I'm aware. That provides any sort of, you know, halfway reasonable physics. There are some simulations based on Google Earth, but you know, maybe something that could be built. But otherwise, even something like AirSim would be very useful, maybe with some imported data for a couple of locations, and that way people can actually play with it around. Have you used AirSim at all? Have you played with it?
Wasn't that the simulator we had at Mavinci? Oh, Cornelius is here. He maybe knows.
You've used it and hate it, or what's the...
That was what was it called? JSB Sim. So in principle, you don't need a user interface on the simulator, because Open Mission Control gives you that already. So if you have a simulator that's command line only, that's basically enough, because it will render the drone within the 3D world in Open Mission Control anyway.
Yeah, so basically,
what I'm talking about is something a little bit more immersive than that. If I pop it into the chat here, there's a link to ArduPilot with AirSim, and if you open that up and just click on the main video there, you'll see the type of you know, immersive graphics and things and simulation of cameras and stuff that you have with AirSim. But it is very resource intensive, as you can imagine, that sort of graphics. But it does, you know, you can do things like, you know, towers and power lines and all these sort of things. And actually, but it might be, not many of our users run AirSim because it's so resource intensive. You need a really fast computer to run it at all decently. And also the data packages which actually provide those environments, they're commercial. And so, yeah, there's only some of them are available.
But on the other hand, I mean, we already have a full 3D environment. You can load whatever world extension you want inside. So what we did at Mavinci, which is kind of removed from intermission control, but should be able to get it back really easily, is that you basically, the software partially knows that it connects to a simulation, and then is adding some additional simulation control buttons like reset simulation, move
speed
simulation
ups
on the other end of the globe, selecting the hardware for the simulation, like, or adding what is the simulation time factor, like Should it be 2 times real time? Because if you want to simulate a 5 hours flight time, it could get really boring. So maybe you want to speed it up.
Yeah,
so
we often run high speed ups. Yes.
Yeah. So things like that we had back then in DaVinci Desktop, and that was even part of the hardware drone environment. So instead of connecting to the drone, you could connect to a simulation and play it with yourself. So really, really low-level simulation is already included in Open Mission Control. As I showed you, he is computing the trajectory of the drone and then checking for collisions and things like that. But it's really, really bare limited. And on the other hand, it simulates you a 3 hours flight plan in half a second on a single core. It's good enough for checking for collisions with airspaces, flight restrictions.
It's more for digging into the interactions between the navigation control inside IGPilot. I don't know whether you got a chance to see Leonard's talk earlier about S-curves and the navigation stuff. If you haven't seen it, it's probably worth having a look at the video we've got up of his talk, because it's going to be really important that that OMC knows exactly how to get IGPilot to track the path that it wants, and not produce any sort of unwanted artifacts like flying through a balcony or whatever.
No, I totally agree. Also, you have to train your pilots, you have to train your software, you have to check if all the user interface runs properly, and you don't want to crash a real drone each time you're adding a new control button, which might not work.
Yeah, exactly. Yeah. We spend a lot of time. We've got a whole bunch of different simulation environments we work with in IGPilot, and they're all basically based on running the real IGPilot just compiled as a binary running on your desktop, and then talking to a whole bunch of different physics backends.
So basically, in a perfect environment, I would even suggest let's bundle such a simulator and such an autopilot with Open Mission Control. So you don't have to start anything separately. You just click a button.
Well, that's what we've got in Mission Planner. Have you seen the simulation button in Mission Planner?
I used Mission Planner, honestly, only very, very little. But
no worries. So there's a button for simulation, and then you can pick the type of, with a fixed wing, copter, rover, submarine, whatever, helicopter. And it then automatically, we automatically build binaries for Sigwin on our build server, and they get downloaded automatically by the ground station, by Mission Planner, and then launched. And then you can then fly against that. So OMC could pull the same binaries, and we could also auto-generate binaries for other platforms if you did extend beyond Windows. And that would give you a way. It's a very cheap binary. The IGPilot binary running in CITL, running at normal speed, really consumes very little CPU. So you can basically have it, and it doesn't require a UI. You can just have it as a child on a string as a process, and then you can connect to it with Mavlink, and then you've got yourself a drone. Or multiple. You can do a bunch of them if you want to, and launch a bunch if you wanted to do some swarming or something. But I think that might be next year after, perhaps not not straight up.
Actually, yes, sure. I mean, you all know Intel. We did a lot of light shows with thousands of drones. So it was obviously that we also thought about getting more than one drone into the software. But the first goal was getting one drone in, and also the entire design goals for the software was it was always a competition between let's get it as user-friendly as possible and as shiny as possible. And on the not for, let's say, developers, but on the other hand, it was very focused on our typical customer base, which have been people doing commercial inspection or mapping flights all day long. And you see there are so many special parameters like tweaking orientation of camera angles, and that's all what they asked for. But still, the design goal was you should never, ever edit manual waypoints. We edited at the end, but we edited very late. Normally, you should not do that.
The other thing I think is going to be incredibly worthwhile to do fairly early on is to be able to run both Mission Planner and OMC at the same time against the same vehicle, and both in simulation and against real vehicles. So, for example, you could to get the simulation, they could launch it using, the familiar technique of pressing the simulation button in Mission Planner, and then it would forward the Mavlink stream to OMC. And that means it'll be less scary for people starting out trying OMC, because they've still got their familiar interface. They know how to fly it. They know all the buttons, etc. And but they've got this additional capability in the form of OMC, and that's something that I think we have to make sure works really well and seamlessly, running them in parallel.
So in principle, we already tried that. So our entire development cycle was based on was it Q ground control?
QGC, yeah.
Kind of all the time together with intermission control, and also several intermission controls connecting at the same time to the same drone. So that was always a design goal. And I think we even did, I don't know, 5-10-ish flights with mission control plus intermission control. Yeah, that should run already. I'm not sure if the buttons
You just need to make it slick and very easy to launch and easy to maintain that link.
This is very easy. We have to check the coexistence, but I think we are already at least either almost or we are already there. So at least we did that all the time.
Yeah, there'll be a few little bits and pieces worth doing.
Sure.
For example, picking the Mavlink source ID, maybe using a different ID to Mission Planner so they can separate out the commands, mission upload, download, that sort of thing. We've also got some new features coming up for much faster mission upload and download, which would be great to take advantage of. So yeah, lots of exciting things to try.
Yeah, you see here we have auto discovery for all their drones and different connection types. So yes, I'm also excited to see how that will work out.
Yep.
So any other question? Otherwise, I would let you continue in your schedule.
No more questions at all? Well, I do have one small announcement to make, and the IG Pilot dev team held a vote over the last week about bringing Marco in as our newest dev team member, and the vote was successful. So you have been voted in as a IG Pilot dev team member, Marco, and so welcome. And it's great to have someone with such experience, you know, with the software coming in, so really delighted to have you present this evening. And it's fantastic to see these sort of capabilities coming into IG Pilot. And I saw there was some excitement on the live stream on YouTube about the sort of capabilities that's coming up. So thank you so much, and really look forward to working with you in the coming months to bring this out to the community.
Thank you. Thanks a lot. Thanks for inviting me. And I hope that will be a lot of fun, and hope that I can get more of the people from the old team working on it. Jan was here kind of at the beginning. He seems to be really excited. So thank you, Jan.
Fantastic.
I guess there's also more people to come. And yeah, I saw here in the chat, what are your plans to get it working after? What are your future plans? I think a bit, maybe you can answer that one question. So after we get it working, we will all do the compatibility stuff you do, like integrating it in your ecosystem, cleaning up the mess, cleaning up the build system, externalizing some of the stuff we did, like we have an own NASA Whirlwind fork, which we want to contribute back to the Whirlwind community and pulling their latest resources. So this is more technical stuff, I think, on the feature level. What I'm really excited about is getting Jan's 3D flight planning in there. And then maybe doing this agile flight planning stuff. And then, I don't know, all this, let's say, the integration between planning and drone connection. That was kind of added at the end, but it's an unfinished business. You know what I mean? So like this agile planning, what I just mentioned, like you're doing just a part of the mission, and then you doing the planning afterwards iteratively. So that would be cool to see it in real life. So we spend so many hours discussing and thinking about it. And I think most of us are quite confident that this is the right way to do it. And I'm happy to every discussion and also I'm happy to get proven wrong. So if anyone has an opinion on that, please join us on our Discord channel, and I'm happy to work with you.
Fantastic. Well, thank you so much, Marco. It's a really marvelous presentation, and thank you, Jan, for coming along, and Cornelius. And so really great to see you all, and look forward to working with you on the OMC Dev channel. And we've got, of course, the Wednesday evening my time, which is Wednesday morning your time dev calls, which is supposed to be a European friendly time. But hopefully we'll be able to have many more chats in the future.
Thank you. And I will try to make it to your planning meeting later this day, but as I mentioned, I have to go to COVID testing with entire
That's
family.
fine. No worries at all.
Thank you. Bye-bye.
Thank you. Right. Bye. All right. So up next, we have Matt Kerr. I'll just take a second to switch over the video recording. Okay, all set. So next up, we have Matt Kerr talking about his rather marvelous, Matt Keir, my apologies, we're talking about his rather marvelous thrust stand system that he's developed. And so, Matt, are you ready to go?
Yeah.
Okay, very good. Over to you, Matt.
Brilliant. Let me just get screen sharing working. Okay. So hopefully you can all see the presentation and hear me okay?
Yep, all good.
Brilliant, thank you. Okay, so hi everyone. Well, good morning, good evening, wherever you are in the world. So I'm Matt Keir, and I'm just going to talk a little bit about the ArduPilot-based thrust stand that I've been developing. This was essentially a sort of one of those really satisfying, fun projects that I started. And it ended up becoming a very useful tool, and it's a very useful tool I'm hoping to share with the community to make something that's just a little bit more accessible for a bit more in-depth vehicle setup. Okay, so a little bit about what I'm going to talk about. So a lot of the design decisions I made throughout this are very linked to sort of the aims of the project, so I'm going to cover those quickly first. Then I'm going to share a little bit around the actual sort of development history, because I think it's fun to look at where things came from and how everything was like super hacky to begin with, and that's all the really fun bits. Then I've sort of split the thing down into two. So there's the actual main controller unit, which can literally be plugged into any load cell based thrust stand. And then there's an actual measurement unit as well, so that adds additional features above and beyond what the sort of normal stuff that you can just buy off the shelf will give. Then there's a little bit around like, okay, well, what data do we actually get out from this, and then how we're going to use that. So I've started making a little post processor as well, which again just makes it a little bit easier for people to just plug this data in and get some useful information out. And then finally, I'll just talk about the future work planned. Okay, so the project aims then, so the idea was basically I wanted to add a new tool into the ArduPilot ecosystem. So we use a lot of electronic motors, speed controllers, and props, but I don't think that the community has easy access to the ability to really compare and contrast different setups, basically. And there are things already available, but they aren't very feature rich. They're very basic. It's often you're reading thrust data off of a little LCD screen, or you're having to shell out a lot of money. So it was to try and make something that was very feature rich, but also very accessible. So what I mean by accessible is I try to keep it low cost. And so everything I'm presenting, if you were to make a carbon copy of what I'm presenting here, it'll cost you something to the tune of about £340 for everything. And I've tried to be as limited as possible in sort of the manufacturing, because this is some hardware. So it's using predominantly 3D printing and then just basic hand tools. And then so this builds on some of the work from Peter Hall, that he wrote the Lua scripting access to the I2C bus, And so this actually provides, in my opinion, quite a nice way of incorporating a driver for an external device into scripting. So it's a really nice way to see that, and then gives people a flavor for how you can kind of prototype those drivers in Lua. And then the other thing I wanted was basically just to offer as much flexibility as possible. Like, you don't have to do exactly as I've done. You can take bits of it and, you know, just make it your own. And that's part of what makes it a really fun project. So, like, kind of some of the history, just to kind of show, like, you know, what I started out with. So the very sort of beginning was very simple, in the sense that so what I took was one of these off-the-shelf units that I bought off Banggood for about 40-50 pounds, something like that, and then a SparkFun load cell amplifier, and then plugged that into my Cube Black and just like started prototyping away to get something basic working. Then I started trying to add more sort of hardware in around that, and you'll see later that a big part of this was trying to make everything very flexible to easily change over speed controllers and motors, that kind of thing. So a lot more hardware and sort of like a dedicated flight controller that's going to, you know, go inside the box all started appearing. And then, you know, the really fun bit, which, you know, is like getting to play with LEDs, so and screens and things like that. And so you can just see some little demos of the first prototypes of the throttle bars that I made with the addressable LEDs, and then using the OLED screens that we've got available in Notify to start displaying some of that data. So this is kind of where it all began, and just getting some of the basics working. So I have already mentioned that it does, you know, this is all done in Lua scripting, and there are very minor changes to RGCopter or RGPilot. So all the examples I've got, the vehicle I have loaded on the flight controller is RGCopter, but it doesn't matter too much. And there's a couple of outstanding PRs that I need to tidy up to try and get in, and then this script will just work on currently master, but probably 4.1 when that's released as beta. So the controller unit itself, and I should say I've got there's a Discord thread as well. So a lot of the information I'm sharing now will be that, you know, I've spoken a bit about on that Discord thread. And if you've got any other questions in the future, I want to follow along on that thread. So talk about the controller unit itself. So some of the features. So there's a Dead Man's Pendant, which is just a momentary push button on the top. And you've got to have your thumb pressed on that, even when the system is armed, for any of the motors to run. So it's just a nice safety feature. And, you know, it's on like a flexi phone cord so that you can stand far away from the device. So like some of the props and motors I've tested make terrifying noise, and so it's pretty good to be able to stand away from all of that. Then we've got an arming switch with the obligatory sort of missile cover. Some aux switches. So I originally just added these aux switches as because potential expansion for the future. There was with nothing specific in mind. There's still nothing tied to aux 2 at the moment, but aux 1 is now for switching throttle modes. So there's transient throttle modes and ramp throttle mode, and I'll talk more about those later. Then there's the calibration button, and so that just takes you through the process of calibrating the load cells, and in this case it's both thrust and torque load cells. And it's a nice little button with RGB LEDs in there, so that it changes color as you step through the different phases of the calibration. And the OLED screen talks you how to go through each thing, you know, apply your load here and press the button again, that kind of thing. So this one is set up so it'll do between 4 to 14S voltage, like a lot of things that I mess around with, sort of around the 12S voltage range. So that was a big feature for me. And then we've got the throttle bar with the addressable LEDs, and that will display the max throttle. So using the user scripter params, you can set what the maximum throttle you want to actually run to is. So if you want to do like reduced tests in certain regions of throttle, you can. And then when you're actually armed and running, you get the change in color bar to represent current throttle. Now this is a really nice way to be able to sort of see you know, where you are in your progress of test, but being able to stand really far away. So you can't actually see what's being sort of output on the OLED screen. But that screen does output, you know, what throttle mode we're currently on, the thrust, torque, current, and voltage values, and that's like particularly useful when you're sort of just trying to make sure everything is working and you're close to the setup. So you can push on the load cells and make sure you're at least reading some sensible values, that kind of thing. But you know, the screen unfortunately is a bit too small to be useful up close. But you know, we can tie in with ground stations for all that information, so we can stand far back from everything and still see all that information anyway. I should say as well, if anybody has any questions as I go, please do just interrupt. I'm happy to just take questions as we go. So this is the back of the control unit now. And this is basically the main interface to the speed controllers. So we've got a little screw terminal for being able to access the ESC telemetry. So from everything from like BL-Heli32, that kind of thing. Then we've got DC power output. Now you'll notice that I've used these terminal blocks. And so again, one of the big parts of this was like, I wanted to be able to switch things over very easily without having to constantly solder and desolder things. And I want to test different configurations of speed controllers with motors. And so part of that was just making it very easy to switch things over to these terminal blocks. So then we've got throttle output, and you know, that's we're running ArduPilot, so we get all the protocols that ArduPilot you know, has as well, which is brilliant. Not that that specifically matters for doing thrust stand testing, but one of the nice kind of fallouts is that this gives you an opportunity to play with a setup and sort of kind of start to get a feeling for how to set that up. So if you've never set up one of those protocols before, again, it's just a really nice thing that you can do on the bench with this. Then we've got some little hold down pegs, so we can just mount the ESC in place and keep it fixed. You know, as I previously mentioned, you know, like when you start using 12S plus, that's 50 volts. You don't really want cables being able to move around and risk shorts or, you know, risk touching the wrong part or anything like that. So this helps just keep everything held down in place and safe. And then finally, so this is the terminal connections between, you know, the three-phase from the speed controller, and then the motor wires will plug in the other side. Now, underneath this terminal block, then I've attached one of these little hobby wing electric commutation sensors on 2 of the phases. And so what's quite nice is even if you're using speed controllers that you don't have ESC telemetry, just by the nature of like plugging your speed controller in, you're automatically getting some way of computing your RPM from your electrical commutations without any additional hassle of trying to solder or plug things in. So I apologize for the slightly messy wiring inside. I probably should have spent a bit more time trying to tidy that up, but to give you an understanding of what's going on inside this box. So we've got Esp Wi-Fi Telemetry. So this is brilliant because, you know, I can, so I tend to sit with Mission Planner open and I use a telemetry screen so I can see live outputs, you know, whilst being far away from the test setup. I can use it for using MAV-FTP to pull all the data back across or just setting the params, that kind of thing. So this makes it really nice to interface with everything. Then there's a buzzer hidden down in there, so you get some feedback using, you know, standard ArduPilot Notify. Then you've got there's a Mauchbeck for, you know, the high voltage down to 5.3 volts, nice clean stable voltage from that. And the high current Hall effect sensor sat there as well. Now, the flight controller I've got in here is the Maytech F765 Wing. So the reason I chose that was basically it's the low-cost controller that has these features. So these features are what was kind of critical to be able to set this, or the things that I needed basically. So the script is quite beefy now, and so it does really need a F7H7 processor on it. To be able to use 2 of the strain gauge amplifiers, they both have the same address. So I've used 2 I2C buses to be able to overcome that problem. There are other ways around that because you can definitely sort of use a MUX to to have them both on one bus, but this is just my approach. And then you need an analog in for your voltage and current coming from the current sensor. Now, I know that there is inbuilt current measurement and voltage measurement on this board, but it's nowhere near the voltage that I was personally interested in. Hence why, you know, I'm not using that here. Then you need one UART for being able to use the telemetry, and 9 configurable GPIO pins. So, you know, so that's for our output, for our addressable LEDs, for our sort of read-in on the RPM from the hobby wing, that kind of stuff. Now, whilst physically attached to the actual measurement unit, I include these as as part of the control unit, and that's these sort of SparkFun quick scale amplifiers. Now, these are the bits where the driver for talking to these over I2C has been added into Lua, and basically these are the sort of the only components that it really makes sense to use these over anything else if you want to use that Lua script that that I've written, purely because the driver's already there for them. And then just another feature, which is like a software over current protection. So I've got this little demonstration. So using a user scripter param, you can set the maximum current you want to, you do not want to exceed. And then whenever you do exceed that current, it trips and cuts all output to the motor and stops the user from still trying to run anything. And, you know, nice LEDs making it very clear that you've tripped that over current. So that's quite a nice way for doing some protection of your hardware as well. Obviously, I'd set the current incredibly low with no prop on that motor for you to see. Okay. Any questions on the control unit before I move on? Super. So the measurement unit then, now this was created partly because one of the things I was personally really interested in is being able to measure torque. And from what I found online was typically you're either looking to shell out a lot of money for a thrust cell, like for a thrust stand setup, you know, or you're going to have to kind of make your own, and hence I started making my own. Now, the design I landed on was to mechanically decouple torque from thrust. Now, I'll talk more about that as we go through, but there are a number of different options, and I've seen people be very successful with sort of not having that mechanical decoupling and just using software to sort of post-process the torque and thrust out from 2 different load cells. So the actual components in this setup then, so we've got the motor mount, which is just 3D printed. And the whole idea here is we need something that just to easily be able to change motors over. So you can just change this basic adapter for whatever motor you need. Then we've got the actual shaft. Now to make this shaft, it's basically an 8mm 3D printer shaft. And then I printed some grinding guides with PETG, and then like just using a grinder, like a grinding disc, just took it down to those guides. So, you know, this certainly doesn't need to be precise at all. It's all done by hand, but you know, you get a neat enough output, and it's certainly good enough to very efficiently transmit the loads through this main shaft. Sorry, going the wrong way. Okay, so some of the components like I've got on here aren't modeled in that 3D model we've got in the background. So just overlaying a picture. And so we can see, so the graphite lubricated linear bearings, there's 3 of them in this in total. And so the reason they're in there is because with this mechanical decoupling, I still need to allow some form of motion. And so we're allowing the shaft to move linearly back and forth through that bearing, and we're allowing the shaft to rotate. So any resistance in rotation is applied purely through the torque load cell. And I tried a couple of different approaches, and I found that these linear bearings are they're actually bushings. These graphite bushings were definitely the best way of doing this, and certainly the simplest. And one of the really nice things that kind of falls out of doing this mechanical decoupling is that any like once per rev vibration that's coming from our setup is being mechanically resisted by the actual thrust stand itself. And so that's not being fed back into our sensors. And that was a big driver for wanting to go down this route, because I had tried just simply attaching 2 load cells, and I found that there was just a lot more noise on the output. So this has ended up giving a much cleaner result. The disadvantage of this approach is that it does represent like having a lot more hysteresis in the system. But I've done some things in post-processing to just check that and overcome any issues that it may arise. So I'll talk a bit about that later. So then we've got some thrust bearings and then the actual collar, which holds the thrust bearing in place. And then this back piece is what I call the thrust cell interface. And that basically is, so we're trying to apply thrust only, but no rotations. And I'll explain more about how that's achieved shortly. Then we've got the thrust load cell itself, the torque load cell, so a point load bearing mount. So one of the things I wanted to make sure is that we're not actually twisting this load cell on its axis at all. So there's a bearing which sits down in here. So there is a point load that's always in the center of that load cell. The actual attachment of that load cell into the main shaft, and then a lug which allows us to put a little arm into the top so that we can apply a known moment to the shaft for calibration. So looking at a cross section of the thrust cell interface gives you a bit of a better idea of what's going on. So there's a thrust bearing here and a thrust bearing here, which aren't modeled then, but we've got the sort of holders just behind them. And then sat down inside here is another one of those graphite bushings. So what this is doing is the thrust bearings are resisting any lateral motion so that the thrust can be applied to the thrust cell. But those bearings and the graphite bushing allow the shaft to still rotate. So no rotation is applied, and therefore no rotation is resisted by that thrust cell, by that thrust load cell. All of the rotational resistance is coming from the torque cell. I hope that makes sense. Oh, I labeled this and stepping ahead of myself. So this is something that a few people have asked me about on the Discord sort of thread that I've been talking to people on. And so hopefully this will help cover off a few questions. And there's been a fair bit of interest around how the torque measurement is being done. So we're looking at a cross section of where the actual torque load cell is. So the components here, you can see the actual shaft, and so this has got one of the grinded flat spots on it to really help the load cell attachment to grip to it, and there's bolts that run through there as well. So this is our load cell, and then this is the mount that holds this bearing. So and then here's the housing that bearing presses against. So basically, the reaction torque from the motor is applied to the shaft. Now, the only thing in this system that then resists that is the reaction load down on this bearing. Now, this means that it gives us the ability to actually measure the torque through that load cell. And finally, just a little sort of breakdown of the actual motor mount. So there's again a flat spot, and this is an interference fit, so there's a lot of friction in here as well. Then there's 2 bolts that run through here through lugs, And then there's actually the bolts to be able to mount into the back of the motor as well. Now, my background is in sort of aerospace mechanical engineering, and so I just get really interested by this stuff. So I made some pretty pictures from a simulation that I did of a couple of the different parts, because when doing the stuff with 3D printing, there's always this big question as to, is it going to fly off at me, or there's a safety aspect to it. So I set up this simulation of like an anisotropic material, so that these are printed 100% 3D printed infill. The main reason for that is to make it a little bit easier for me to simulate and get a bit more confidence in that we're not going to be, it's not going to be failing. And so you can kind of see how the load is being applied, and where the main stress is appearing on those bolt lugs. This is conservative because I've not actually accounted for the interference fit and the friction on that surface. So anyway, everyone likes pretty pictures. So the actual data output. So the data is being dumped to a CSV file, which can be easily accessed using mapftp. The main reason, well, there's two reasons for the CSV file. One, it was just the easiest way of doing it actually in scripting, and two, it's also the most accessible form of data. So nobody's tied to actually using the post process that I'm using. You can quite literally just put this in Google Sheets or in Excel and plot the data yourself, and so the barrier to entry there is very low, which is I found appealing. So I've got a list of the data fields that are currently being stored and output, which I've largely talked about already. Just a couple of the points is that the actual RC out. So I'm using Arducopter as the vehicle. So I'm actually using the mot PWM min and mot PWM max parameters to set the max and min PWM out, or throttle bands basically. And then similarly, because we're using the ESC telemetry, if you're using an ESC with telemetry, then you just need to make sure that the servo BL heli poles is set or configured correctly for your motor to actually get a sensible reading for the ESC RPM. And something which I've never even really looked at before, but it's really useful for the thrust stand, is actually the ESC temperature. It's not the most high fidelity output, but honestly, this was great because I've been close to melting some ESCs, and so it's really nice to have that temperature output. So another function that we could add potentially is temperature protection, much like the current protection works as well. So this is showing some of the actual data that we're getting out, and it's quite nice to contrast between the two throttle modes. So I previously mentioned a bit about this. So we've got our nice sort of gentle throttle ramp. Now, what this does is just gently increases the throttle, and then holds 10 increments all the way up to max, and then steps all the way back down. So you can loosely see in the thrust, there are actually two traces. There's the run up and run down. Now we're doing that to be able to attempt to capture any hysteresis in the system. And I hope you'll agree that there is very little in this system. So when I started seeing some of this data coming out, I was very pleased. This is for mainly, what's our max thrust, and how we, what's our, we can use this data then for our thrust expo parameter for linearizing our output ready for ArduPilot. So then a little bit more niche, but very interesting, I thought was, so this transient mode. So the way that the transient mode currently works is it reuses the hover throttle parameter. So you set whatever value your vehicle is going to hover at based on using your ramp. So once you've set that value, it'll slowly ramp the throttle to hover, and then it will start applying a like step inputs based on a table that's in Lua either side of that hover throttle. And so where I was interested in this is for looking at speed of response of some different motor propeller configurations. But one of the really nice things is I heard Leonard talk a lot in the past about, the difference between the speed of response of torque versus thrust. And you can categorically see it now, like torque, as soon as the change is applied, we get this humongous spike and we don't actually manage to capture the peak of torque. And so the torque is instantly applied and then it comes down to some steady state constant. Whereas thrust, you don't get that same spike. That's the thrust slowly, comparatively speaking, ramps to that. You get that roll off in thrust. So that's really nice to be able to sort of physically see something that that I've heard a lot about in the past. So there's still some work needs to be done around throttle mode transients, because at the moment it's not very user friendly in terms of being able to configure, because to have a sensible point of comparison between two different setups, what we're actually caring about is that we need to have this step change needs to be a consistent thrust change output, so that we can measure the thrust output versus time. And at the moment, because we control via throttle, I have to say I want a 20% step change. I have to come in here and actually measure or look on our throttle ramp what that 20% throttle is, and then go and input that into the table in Lua. So I need to do a little bit of work just to try and make that a little bit more front end accessible through some parameters, perhaps, to make that easier to set up. Okay, and then the post-processor. So I've started putting together a post-processor, and big asterisk, this is really clunky at the moment, so I need to do some work to tidy this up. But it's Python-based and using Tkinter for the GUI. Then it's very useful for, you can just output and plot the raw data. It has automatic run detection in it. So if you've done multiple ramp ups and ramp downs in one log, you can actually separate those out so that you can look at those individual runs separately. It's not shown here, but there is support for taking data from other thrust stands. So there are other automatic thrust stands that they output in CSV formats. So you can take that CSV format and you can convert them to what this process is looking to see. Then we've got a number of filters. So sometimes the data can be very messy. So this is just a way of trying to clean that data up. Then we've got some automatic Expo fitting. Again, this needs a little bit of refinement, a little bit of work, but it works in the exact same way that the Google Sheets works. And again, having that CSV file, you can just drag and drop the data from the CSV file into the Google Sheets that we have on the wiki, and it just works. And then I've also got Coax Grouping as well. So this is a crude, but it does work way of looking at coax data from this thrust stand. So you can see we've got the actual sort of measurement unit here, and then we've got this sort of dummy holder for the other second motor. And what we do is we run the motors in one rotation so that we've got thrust going in one direction. So it's hard to tell from the image, but let's say, for argument's sake, this is currently the bottom motor. So the thrust generated will be going in this direction. So this will be the top motor, that will be the bottom motor. And then we flip the motor rotations and the propellers, and then we can then measure this as the top motor and this is the bottom. And for these motors that were on test here, here's some of the data that came out. So you can see you got the top motor and then you've got the bottom. And what the Coax grouping allows you to do is basically add the two together. So you can see there's been some interpolation and some filtering just to bring that data. It's quite minor, but it gives you the total output, which then allows you to use to apply your thrust linearization to a Coax grouping. Is this method perfect? No, but it's pretty good. And one of the cool things that kind of I noticed coming out of this, and I haven't actually got a graph to show this, but In this coax setup, the top motor, the thrust profile is essentially the same as if the motor was on its own. It's largely unaffected by the bottom motor. Now that's probably something to do with, or probably more related to this specific setup more than anything, because the disk loading on these props is very high. The exit velocity from these propellers is very high. But basically all of the inefficiencies and all of the losses in this coax setup are all coming from the bottom motor. And with this kind of setup, the high sort of throttle region, we're getting significant losses. So I'd need to look at more data, more motor setups, but this is starting to indicate that there may be a genuine how can I say, case to start doing per motor throttle expo, so that we can do per motor handling in coax setups, so that we can try and achieve something with that's a little bit more efficient, but we're still having the redundancy that some of these coax setups tend to afford us. So future work then, I'm currently working through a bug in the Lua script whereby every now and then the thrust data sort of just stops working. Now it's something to do with the I2C bus and the it's not like a setup with the amplifier or anything like that. It's definitely a firmware issue. So I'm just trying to kind of work through that at the moment before this kind of gets pushed in. So then I want to tidy up the post processor because it's a bit of a mess at the moment, and then that code can be released and everybody can just modify it as they please or add things or that sort of stuff. Then eventually I want to go to a larger measurement unit. The thrust capacity on this, I've taken this measurement unit up to 10 kilos, but it's a bit small for that, and it all gets a bit terrifying as well. So I'm going to make a bigger one, but without being quite as constrained on the price. So it is larger. And then what I want to add into that larger one is the ability to do dynamic mass balancing of props and motors for that larger unit as well. And that brings me to the end of the talk. So thank you for listening and welcome any questions.
Fantastic. Thanks, Matt. Just a quick note about that Google Sheet. I wouldn't completely trust that sheet. That was done by me originally. It was based upon a MATLAB script from Leonard. And then I sort of translated MATLAB. And given I'm not actually a MATLAB programmer in the first place, that was one source of dodginess. Plus, there was a little bit of confusion regarding the spin min and the definitions of where things happen at the low end. And so Leonard and I went backwards and forwards several times, and I don't think we got to a final resolution on having the definitive Google Sheet that's definitely the one you should use. So I'm not offering you a solution here. I'm just pointing out that I wouldn't take it as gospel.
No, that's entirely fair. And when I say that it works, the Expo fitting that I've done works in the same way, I mean in that it still handles the voltage scaling. It's still but it's essentially automatic, and so you kind of hit a button and it just configures all of the values to what it try to optimizes the curve. It does a best fit basically.
I think we need some reference data sets, and those reference data sets need to be probably gone over manually by Leonard to get what the reference expo out of that data set should be, and then ensure that our tools like the sheet and your tool produce something close to that manually calculated, because Leonard does a whole lot of little tweaks and things when he looks at a set of data. I'm sorry for talking out of turn, Leonard. I know it's your baby, but I think a reference data set with the correct answer would be a great way of us ensuring that we consistently produce something that the end users will get some value out of.
Okay.
Yeah, it's a little bit tricky too in that like the voltage scaling is one of the most important things, but part of it's there's some approximations in the code. The knowing what your spin min, spin max is actually going to be, not just your minimum maximum PWM, changes that Expo because it narrows the range, especially the spin min. The higher that is, the lower the Expo, because you're working. So there's a few things like that where you can't actually calculate the true Expo unless you know what your spin min is that the pilot or that the aircraft's going to use for that safety thing at the bottom. But the equations themselves are pretty straightforward. It's a bit that I struggled with trying to do it in this. I'm used to running in MATLAB, so.
Yeah. And look, Google Sheets is a terrible way to program. It's just very accessible. Right, that's why. You mean lots of people can easily just, hey, I'll just copy this sheet, throw in my data, and I'm done. They don't need to buy a copy of MATLAB, and it runs on every platform. But as a programming environment, God, it's awful. It's silly.
Yeah, it's terrible. Like, I'm sure we could do better. And I've went through, must have been 20 iterations of it to try and get it right.
I mean, maybe a JavaScript, would be better. Actually, a JavaScript web page might actually be better, because at least it's a somewhat sane programming language. But anyway.
But yeah, great job, love it. I've done the same, something similar. My motors and propellers are a little bit bigger than what you're using, and perhaps a little bit scarier. I do envy the 5-inch props, but I sort of did mine was just an Arduino thing, but I went through a lot of the similar things. I ended up doing a tri-dual strain gauge version to get torque, and it's great because what I didn't see in any of your pops is the motor efficiency calculations and that sort of stuff that's right there in that data as well, that I found really useful and interesting from my results. So great work. I was looking at that enviously. What sort of update rates are you getting on your strain gauges?
So on the throttle ramp, I'm just using 10 Hertz, but then for the transient, I'm up to 80 Hertz.
Yeah, because they say 80 Hertz, but it didn't look like I could, with my test, and it might have been my strain gauges or something, but it didn't look like I could actually get far, like I would see I could output it fast, but it was like the strain gauges took a while to change value. I wasn't getting the instantaneous response out of the strain gauges, so I didn't feel like I could get an accurate time response, because I wanted to measure the reaction time of the motors in exactly the same way you did, but you seem to have got much faster response time.
I think it depends on your amplifier more than anything, because that's certainly what's limiting this thrust stand is the rate of the amplifiers. And the thing to be clear, so I'm requesting 80 Hertz, and when I'm looking at I've got a little plot which shows how that the actual logging rates was being achieved, and about half of them are being achieved at about 80 Hertz, and you can see there's a lot of dropped data. Now I don't know at the moment whether that drop data is just because of noise on the bus, or whether it's just because I'm just pushing that amplifier a bit too hard. So still to kind of be worked out.
Yeah, for me, it wasn't the amplifier, because I'm using exactly the same amplifier you are. For me, it just seemed to be the actual the response of the strain gauges was slow, and it might have, I don't know why that would be, but yeah, I just was wondering if you'd seen anything like that yourself. Like when I look at these things, I'm probably doing something wrong or something silly somewhere, but I've
never noticed that, but I mean, I'll certainly look for it. I never considered it purely because I know that people have used strain gauges for measuring, quite high frequency vibration. And so I am surprised by that, but like, it's definitely something I need to look
well, that's why I was surprised too, because when I saw your data, it looked like you got really nice fast responses on your torque and that sort of thing that I didn't. So so I don't know what I'm doing there. But
Not sure. Brilliant, thank you.
All right, well, thank you very much, Matt. That was absolutely brilliant. Love the project. and really appreciate you coming and presenting at the DevConference this evening. So I will just switch over the recording before we start. Right. Okay, so I've got recording going for the next session. So the next session is our dev team planning session, and this one is always a bit ad hoc. Actually wanted to start it off a little bit of an administrative announcement. I announced during Marco's talk earlier that Marco had been voted in by the dev team as a new dev team member. And in fact, there's one other person here this evening who's just been voted in as a new dev team member, and that is Michelle. So Michelle, congratulations. You were voted in as a dev team member and the maintainer of Blimp. So congratulations.
Thank you.
So, the planning session, as I mentioned, it's sort of a bit ad hoc each year. And I put out a link earlier to we used a Google Sheet last time, and we all just sort of went in and hacked it simultaneously. And I'll put a copy of that now into the chat in case anyone, wanted to reference it. And that's it there. And for the people on the YouTube live stream, my apologies. I know it's going to be very difficult to click on that, but you can squint at it and try and type it all in, I guess, or I'll go and shove it on the other chat in case anyone wants to.
You can screen share it maybe too.
Yeah, that's on the chat there. So that's what we did last time, but there was also a suggestion earlier, a little bit of side discussion about whether we should be doing it on GitHub. The main advantage of like using a Google Sheet or a Google Doc is that lots of people can edit simultaneously. But the advantage of it being in the GitHub is that, it actually provides us with a more permanent, project hosted way of storing this. So, Randy, do you got any opinions on which way we do it?
Not really, not much of a strong opinion. As long as we pick one.
Right. Okay. James, you're often the person who ends up doing the herding of cats to get us into some reasonable shape for this this part of the thing. Do you have a preferred approach?
Look, as per I guess the side discussions, the problem with doing it in the Google Doc is that people don't then refer back to it. So there is a lot of benefit in having it visible and hosted in Git, and also we can then link the work that flows out of it back.
Okay. So if we go to, I'm happy to try it in the Google project, and so this shows us like project number 1. We have had earlier projects in the RGPilot world. This is
maybe share your screen, Rich.
I can indeed, yes. Just hang on a second, and I will share my screen. All right, are you seeing my screen there now?
Randy, like that, eh? I turned into a ghost man. It's reversed.
Oh, it's reversed.
Oh, sorry, my camera was reversed for a moment.
Right, okay. So here we are, RGPilot projects number 1. Now, who is familiar with this interface? You just sort of throw in a whole lot of to-dos in this column, or I haven't used this interface before.
So, sorry, James, you want to do it?
No, go, Randy.
So I was filling it in earlier,
if you look at
it's a bit like our projects, right? For our releases and stuff, when we pile up the, all the commits and stuff. In fact, it's the same interface. So my thought was just that, for each section, like for example, like copter navigation, for example, we'd create a single card, and then we would stick, we'd list up all the issues for that section within a single card. Right. So that's the cards, I guess. Then you can see, so you click on that button to add a card. So if you've got like a new category, you push that little plus and add it in there.
Yep.
I think everything goes into this to-do column. It doesn't need to be though. Another idea would be, instead of just sort of split it by time, like, to-do or in progress, we could we could put the categories at the top here. So, we could have, copter navigation or plane or whatever as a different column. So that would be another way to keep the list of items in a single column, maybe make it more readable. So that might be a good idea.
Right, okay. Now, the other thing we should do is, I think we should briefly look through what we had down from last year and which ones are still pending, and which ones we can sort of cross off from here. Quite a few, there were some duplicates. I noticed that bidirectional D-shot was in there twice. It was put against my name, and luckily Andy went and did that. Thank you, Andy. But there are some items on here that are still very much pending, like the FTCAN. We can support FTCAN devices, but we don't yet run them at high rate. And so that's obviously a major one. So that would go in the to-do. Would that be right? So we'd add a,
yep.
Everyone's still there. So we basically add FTCAN support, 2 forms of FTCAN support, one using v0.9 let's see, message format with 64 byte frames and 5 megabit CAN rate, one using V1 support. So is that a reasonable summary?
I guess, I think, you don't need to be too detailed, because you can also link in an issue. So if you've already got an issue, you can just link it. So, you can make it like FTCAN improvements or something like that or whatever.
Yeah.
I mean,
we don't actually have that as an issue at the moment. It's just really been Sid and I having a bit of a discussion. We haven't really formalized exactly the approach we're going to take, but that was a rough summary of what Sid and I have discussed.
The other thing I would add into each card is just who's responsible. So it's a bit like our GSOC projects or something, everybody's got an opinion, of course, on what they'd like to get done, and that's totally cool. And we want to talk about that too. But what's key, I think we're only gonna put things on the project list if the developers actually step forward and says, this is what I'm planning to do for the next year.
Right. Okay. And it seems to be done by.
Yeah. I'd put it in brackets, maybe. Yeah, exactly.
Up the top here.
Either way,
that seems to be the approach.
Yeah, something like that.
Yeah. Okay. All right. Well, I might bring some of the other ones across that. I mean, a lot of the items actually, I was pleased to see that this last one, most of the items that had my name against them last year, we've actually done. Not all, but most of them, I think.
So I think maybe each developer should, maybe use last year's as a reference if that's useful to them. Also, a lot of people, of course, in their talks, right at the last page of their talk, they had a list of things that they're planning to do in the future. So that's another good reference. But yeah, I think each dev should basically go in there and create cards for the projects they plan to do over the next year.
May I do a suggestion?
Sorry, what was that?
May I do a suggestion?
Oh yes, of course. Anyone can make a suggestion. This is a very open.
Okay. This is a Kanban, yes. Just a single column to-do list. Maybe it goes be too big with something that someone will do for sure, and something is just is a desire without owner. For an example, last year I tried to put my name in the new website and the translation as well, and I did none of those. Okay, but there are some things that maybe is just a backlog without an owner. And everything inside the same to-do list, maybe the to-do list will be very, very big.
I think
another.
Yeah, sorry, I totally agree. And I also think that you shouldn't feel too much pressure. We put things on the list sort of to give people an idea of, what's going to happen over the next year, so that it helps them collaborate, look for points of collaboration. The point is not really so much to put pressure on that person to get this thing done or that thing done. We all have enough pressure anyway, so that's not the goal. But yeah, so I think put things on there that you'd like to do, but there's no shame or foul if you don't get it done. It's more just to promote collaboration. But I also totally agree, though, about your point that one column is too much. So I think we should add columns for different sections.
Yeah, so last year we had hardware and OS support, we had scripting, we had EKF planes, we had different categories, and they should be columns, I guess, by...
I wasn't meaning too many columns like that. I meaning maybe 2 columns splitting what the to-do list is really been doing, or someone already asked it to do or gave it its name, and a backlog list maybe with something that we desire but we do not have an owner. For an example, Trich, we spoke some moment last year regarding move some building logs from the Autotest server to the Wix server, maybe. Do you remember? I could not help on that, but maybe it's a column with things that we wish, but we don't have someone to help yet.
Mm-hmm.
Would be easier for someone new get something to do, because a huge single to-do list maybe is kind of confused to organize. It's just an idea. It's not idea to have so many columns. Just a suggestion.
Yeah.
Created a bunch of
I
columns
used to see
there.
this. Sorry, Randy.
Oh, sorry. Yeah, no. So I just want to say I added a bunch of columns as you can sort of see. One for copter, plane, rover, systems. It's getting wide now instead of tall, but.
Can I move things between columns? I can.
Yeah, just drag them.
I can just drag them, can't I?
A project for each vehicle, each with columns in.
So I'll just go and make this. I'll try to rearrange my screen.
So earlier today, I created 3 issues and tagged them so that it appear here. If you have a look, you see the plus add cards, 3 new in the top right-hand corner.
All right, okay.
So if you click on that, you should be able to drag them down into the relevant.
I'm just adding system ones across here. That's probably a system 1, FD can. Okay, now these ones here, these 3 new cards. Feel free to get in here and edit, Peter, too. Simulated SPI sensors, great. So I add that in system level. CIDL level parameters to wiki elsewhere. So this is, do we have a docs column? No, I think we add column documentation.
Do we want to add PRs, I guess, the PR into these columns, or are we just adding text of what things we're going
to link to PRs are a good thing.
Okay.
And I'm just putting these across. Yep. In the short term, I'm just going to be focused on the plane 4.1 stuff, but it's good to have this sort of structure around other things.
Maybe Bill, maybe I'll put copter and trad heli together here. Doesn't have to be the single column.
So as I say, I think like if we're trying to be Kanban, we ought to have a project per vehicle, and then each vehicle would then have its own like to do, in progress, needs review, done sort of thing. If we were sticking to Kanban, that's the Kanban way to do it. If this just is
no
a
idea
list
what
of stuff.
Kanban
Yeah, Pete,
is.
Never
heard of it.
Let's not try to be too fucky too soon. I think we get all the ideas in here, and then we can play around and clean up the formatting afterwards, because once they're in here in the cards, then we can move the cards around at will.
Okay.
I think the
vehicle
purpose
is not a good idea, Peter, because you have things that are common to vehicles. So then you should have a common one.
Yeah, so you would add a common project.
Yeah. I don't think this allows you to create links between boards.
Yeah, I've already bumped into that with this, like, I guess you could have an EKF column, or maybe that's a system column. I'm not sure. Like I got this copter rover object avoidance section for Reshab and I, and anybody else. And it's not sure whether to put that under copter or rover. You're putting everything in a to-do systems, eh? Isn't everything to-do?
Yeah, Randy, I think you and I were both adding columns at the same time. So there's a little bit of duplication that just happened in the ether.
Okay, I'll get rid of this one here. This I think everything's to-do, so I don't think we need to have separate to-do from non-to-do.
I'm just having a look now at the other stuff off the previous roadmap.
And Randy, I added a heli, but we can go combined. I'm not sure how you want to do that. So,
Either's fine. Yeah,
just... I'm okay with either.
I would go for separate because heli have different requirements than multi-rotor.
Yeah, cool. I got rid of the copter. Sorry, I got rid of the heli from the copter.
Okay, great. Yeah, I already added a heli in there.
So where would the obstacle avoidance stuff with copter and rover go?
Hey, Reshab. So I've got this one section. Oops, of course you can't see my cursor, but you see how even on Tridge's screen there, just below projects, there's a copter column, and I've just got one card there for copter rover object avoidance.
Right.
And I've just got one item in there. So if you want to.
Okay, so I just add a number 2 there and go on. Yeah, makes sense.
Randy, this object avoidance should go to systems because it is common between vehicles.
Yeah, I was wondering what to do there. It's mostly.
I don't think it's bad under. I think the development is likely to happen within Copter, and then the rest of us just going to benefit from it. So I think it's going to be a Copter-oriented development, even if it is available in others.
Yeah, that's where like 80% of the work is.
Yeah, it's like S-curves is plane and Copter in principle, but in practice it's Copter.
Yeah, those are going to systems, not specific to vehicle.
How do I combine?
Oh my God,
these?
We're doomed. We are starting doing Kanbans. Now we just are missing the stand-up meetings because everybody is sitting down. We need to do stand-up meetings.
Matt looked like maybe he was standing up during his presentation. Is that a standing guest you got there, Matt?
Yeah.
Cool.
I had to just go and look up what a Kanban is.
Yeah.
It's a rabbit hole, Rich. It's a
Let me know what you
big rabbit
find.
hole.
I'm going to stay
It's
right
an
here.
Atlassian thing. Yeah, I immediately dislike it if it's got Atlassian in it.
No. It's a general project management.
Well, the first hit on Google is Atlassian, so it must be bad.
What do you like about Atlassian?
I'm sorry?
Did I kick your dog or something?
Oh no, it's just every time I've gone to use the Atlassian tools, I've just found them utterly befuddling. I think it's because there isn't an Emacs mode for it, or so that's probably the problem. I've just never got into the swing of that set of tools.
Kanban is actually a Japanese word. It means like a signpost.
Oh, okay.
So all this stuff comes, it's like, it's agile software development, right? It's it comes from manufacturing originally, and then it was adapted for software development.
Yeah.
I don't think we necessarily need to use it as a Kanban. It's just a way to collect what jobs we want to do, right?
Yeah. Looks like Leonard's filled in the copter control section.
Yeah, and I'm trying to reorganize the stuff now so I can actually start preparing some PRs now everything else is done.
I'm pretty happy with this list, actually. I'm embarrassed that I haven't done the high-speed USB support yet. I promised CUAV that I would do that more than a year and a half ago. And I've got the hardware, so I've really got no excuse. But yeah, I've just got to get in there and implement it.
I wonder if you should move Andy Piper's generic ESC NUT support maybe over into systems.
Should we had a big one of an ArduPilot ESC?
Ooh, that sounds good. Systems column is huge.
We should also consider some of these dictators good first issue, because while they're important to us, they might be a sort of thing that a new user could do.
So you're breaking up a little bit there, Peter. I couldn't hear that very clearly.
Peter, we're trying to put things in that the developers have committed to doing. So the issues list for new issues is already.
By the way, Tridge, did you we've moved across to EKF3 for plane on master, or are we still on EKF? Yeah.
No, we are. All vehicles default to EK3.
All vehicles are moved across. So if there are any features that are needed at the moment, they're obviously not ones covered by auto test, but there may be still some niche EKF2 features, which are or behaviors is probably a better description that will catch us out when.
Yeah, people have been flying it actually because it's been the default for small fixed wing aircraft for ages, because all the 1 meg boards switched to EK3 only, you know, like a long time ago. And so people have been flying it for ages. There have been issues. I mean, you know about some of the issues that Henry's did and others. And the overwhelming feature we need is robustness and confidence in it, in all the weird environments that people have, you know, when they've got rotten compasses and bad GPSs and, you know, or the other way around, you know, all those issues we've had with RTK and the variances collapsing, those sort of things. And I think you've been chasing those down really well.
Yeah, I've been chasing them down. So I think that one, we're so close to being able to turn off EKF2. I mean,
that's right. That's right. It would be, we'll probably leave it there for quite a while on the 2 meg boards, but we'll have it in reserve to basically, there's another 100K of flash, you know, when we finally decide to pull the plug. But there's...
Well, we can't really remove that until we get another estimator in. So, Paul, EKF4?
Yeah. We want another estimator. Oh, crikey.
We might end up with an EQF coming in.
Well, that'd be really nice to do that. I'm going to have to ping Rob.
Well, they've got a student working on that, of integrating that into ArduPilot this year, Angela, working with Peter. And I've been helping her with using replay logs to feed the EQF. But it's a longer term project because they're not initially trying to do all of the little edge cases. The different sensor timings and things, for example, they're just ignoring to start with. And obviously that has, you've got to take into account the delayed fusion. Yeah, it's going to be really interesting to see how that develops.
Randy, just a comment on that object avoidance card that you added. Usually it's easier to have one card per item. So you have one card for loiter, one card for easable multiple depth camera, so not to aggregate so many to-dos.
Yeah, I thought about that, but then I thought, we're just going to end up with, this sort of, I thought this might help the grouping. And, if you just have too many sort of individual elements, they sort of, you can't see that they're all part of like the same, project.
Yeah, but it makes it very hard then to manage, because there are points that might move forward faster than others, so you have the cards staying there for too long. So it's easier to do. Just a comment from someone that has been fighting against Kanban boards for a long time.
I was thinking that instead of actually using numbers, we could use these little checkboxes, maybe, especially once, like, everything right now is new and hasn't been done yet, so it's maybe too early. But I always think of checkboxes.
There are pending PRs from some of the system ones.
Yes, but they haven't been done yet, have they?
Haven't been merged. I could go and merge it now and prove you wrong.
Well, okay, then we can add a checkbox. So that's all I'm thinking, is that we could change some of the number of checkboxes.
Randy, do you have all of the external app support you require at the moment for Copter and Rover?
Yes. Yeah. So I was looking at the to-do list for 2021 or 2020, I guess 2020, and I think we cleared off the EKF issues.
Yeah, because I was thinking that what I want to focus on now is the family member that slams doors loudly. What I wanted to focus on now was just really starting to look at making sure we've got improve the robustness.
Yeah.
And also the other item was we're going to get a greater sensors coming on board in the next 12 months or so. That's really an order of magnitude.
Sorry, order of magnitude more accurate? You mean, did we lose Paul? I feel like we lost Paul.
Sorry.
Yes.
So we've got sensors coming on board that are an order of magnitude better, like the ATIS, but even the latest generation of ICM IMUs, and particularly with the temperature calibration. And we haven't revisited the base tuning of the EKF for years. So probably be a good task to put in. So I might put that in.
Cool. Maybe we need an EKF section. I've actually got this EKF GPS and non-GPS improvements. So if we had an EKF category, we'd.
Yeah, I'd actually like the defaults for the EKF to automatically change based on it querying the AP inertial sensor library. First of all, asking the library, have you been temperature calibrated? Because the library knows whether it's temperature calibrated. And B, for this particular sensor type, what the expected range of sort of drift and noise and things is. And then it automatically sets some default values. I think that would be a big win. So people on the really high quality boards get an immediate benefit without having to retune it themselves.
Yeah, I think it's mainly the bias, how much we allow for bias swing and rate of change of biases.
Mm-hmm.
So should I add another section just for EKF?
I've added an EKF column here. Maybe we could do it like this. Sorry, just move systems to the front there. I don't know. It's the biggest one.
Oh, just add a column that is polls column.
I want to be
everything related to poll.
I want to be there too.
Actually, with the sensor selection stuff, Randy got the bit between his teeth, and he was really getting into it.
Oh yeah,
it was a lot of fun. It was a huge amount of fun. It was difficult, but not so difficult that I couldn't actually do it.
Yeah, and he cleaned up some of the code in the process, which was good.
Oh yeah,
and
really nice
also did lots of testing, which was even better.
Yeah,
that was a great project.
Yeah. Michelle, do you need a blimp column? No, we lost you off the call.
I guess. Again?
We do, right? Blimp.
Well, if you want a blimp column, we can add it.
We could put blimp.
Yeah, it's kind of early in the planning now.
Anyway,
I think that no pressure. Do everything.
Implement blimp. That'd be a great item.
Already implemented, right? Flies.
Yeah, but I mean,
swimming around.
Yeah, navigation and things, and also getting a release out.
Yeah. Speaking of which, actually, Tracker, right? Is Tracker going up there?
Yeah,
we could put a general
4.1 for Tracker.
We could have just an other column if we wanted for some of the smaller.
Yep. Well,
just to limit the number of columns. That's all I'm thinking.
Some of these sort of administrative things, are we going to bite the bullet this next year and rename Arducopter to Copter and Arduplane to Plane?
I'm quite happy to do that if
sounds
people would like me to.
There was a bit of pain in that, if you remember, with doing when we did Rover.
But I kept a document to track all of those pain points.
Oh, okay. So. Yeah. I mean, I forgot there was a few ancillary things that were painful. I think probably the biggest burden was on Henry, I think, with documentation. But there were a few others as well. There were some surprising ones that affected Mission Planner and
issue 14,091. If you can think of anything that isn't on it, then you should probably add it. I'll drop that link into conference chat.
Well, we could, stick it in here under a general one or under each vehicle.
Yeah, I've just created it. I mean, it could be. I don't know if it's one. If we do it individual vehicle by vehicle, or if it's just one project that we do for all the vehicles at once.
So, what was the PR number, Peter?
Issue number 14,091, 14091.
14091. Okay, I will reference it, and then I can go and. It didn't link it. Damn it! I was hoping that the hash syntax would work, but I'll go and.
We have to name the project. So rdupilot/rdupilot, that number.
We're on the rdupilot project, right? So it should be
automatic. You're up in the
organization rdupilot.
It just actually appeared on the right-hand side of your screen, Tridge, under Add Cards. I can see it right there.
Okay, well, yeah, with my desktop screen sharing, I can actually, I can't see as much of my screen as you guys can.
Down, yeah, I'll just navigate your cursor for you.
Yeah, that's right. It's you might need to. All right.
You just mouse over it. Actually, it's just a little bit further up.
A little bit further up. Yes. Okay. So I can sort of. Yeah, okay. Well.
Whatever.
Copy link address. Edit note. So I can move this one back to where?
System level.
Just delete it.
Yes. Just delete it, I guess.
That's definitely like a through, at least 3 months after 4.1 is out the door for you.
Yeah, there's no massive rush. It's just a nice, neat thing. The other one related to that is rename rdupilot mega.xml to rdupilot.xml. Although I was thinking we might add the ability in the PyMatlink generator for an alias, because otherwise a lot of external projects depend
you don't need it.
on
You
that.
just inherit. You just inherit the other one.
You can inherit, but I was thinking more like an alias. But yes, it could just be an inheritance.
Something we should discuss is moving AP perif to be a top-level vehicle.
Yeah, Tom's very keen on that, and I think probably we should. Logically with the others, it should be just called perif, but the AP perif name has actually become reasonably well known. Probably AP perif.
I think perif is better because you have plane, copter, and blimp. So I think we should be consistent with naming. So perif, I like
perif. I think perif, the binaries can be called, AP perif like RDcopter. Binaries are RDcopter.
Yeah.
We still have RDcopter, RDplane, RDrover. It's just that the directories are rover, plane, copter.
Yeah, I do agree about moving it out of tools. It was back when it was one CPP file and 200 lines when it was in tools, and it sort of made sense. But it's grown up a bit since then.
Yeah, I had a bit of a rethink, a quick rethink during the last presentation from Matt, where it was kind of, oh boy, ID thrust down. But thankfully, it's just a script at the moment.
Yeah. Now we don't have Michael Dubois here, so can I propose rewriting the code generator, the compiler for the Lua generator in Python out of C?
What shortcomings do you see in the existing implementation? That
it's just about unreadable. It's just
compilers, hard to hack on. Yep.
Yeah, it's very hard.
It's working quite well now, though.
Yeah, it
needs
works,
fixing
but
then.
The string handling in C leaves something to be desired.
I think it's getting quite clever.
And speaking of Peter Hall here, I don't see you much up on the Kanban.
Yeah, I mean, I was going to do some stuff last year, and then I did completely different stuff. So
I was wondering if that might be it, because I know you got your hands all over the code.
Yeah.
We could add
not know what you're going to do.
A submit thesis item in here, Peter, if you like.
It'd have to be its own project, I think.
Question is, who gets assigned to that one?
There was a lot of self-restraint there, Peter. I completely understand.
Well, you all need to stop doing such interesting things, and then I can concentrate on my thesis.
Pete, you could just bite back at Tridge and ask him what his thesis started out as and what he submitted.
Yeah, it did meander a little bit, quite extremely. I frustrated several supervisors. Right, this is actually looking pretty good. Now there's a whole bunch of thing in search results here. Are there others that are pending here? New activity.
So am I thinking right that these cards are kind of just very minimalistic thingies? Like they're not an issue, so they can't have an owner or anything like that. Whereas I can see these other thingies here.
They should have an owner. I think every item should have an owner.
Yeah, but I'm just looking at the RDcopter renamed to just Copter. It says added by Armacry 9, but nothing more.
Yep, you're right.
Oh, I know. Under plane, what I think I've got to add, Henry would want me to add, improve tuning.
You can convert it for you can convert a card for an issue, and you can use an issue as a card.
How does one go?
Yeah, I was going to go through it rather than confuse people now.
Convert to issue. There it is. Right. Good.
Who should be the board master?
I was starting to think, Paul, about the auto tuning technique that we've found has been working quite well for the fixed wing. Whether we could apply it to the tail sitters.
I think. I mean, there's
at least the feed forward detection.
The feed forward detection probably, I need to talk to you about that because that yaw axis has got a few wrinkles to it with feed forward. And yeah, well, I think we probably want to have an offline conversation about that.
Oh, sure.
I found it,
all now.
It required a slightly different tuning technique than the other axes.
Yeah, and don't forget that tail setters are running on copter PIDs, basically. It's even the flight controllers are on the copter. The flight surfaces are on the copter. So it's not really plain at that point.
Now, I should put in the link to your text PR, Paul. Let me see.
Oh, the acceleration vector,
yeah, that one. And the other one is all the new Barrow stuff that we've done for that glider project. So that's the experiment in tighter integration of horizontal vertical tracking, that one. So it's not just text, I know, it's much broader.
I know,
than
it was
that.
one of those things where I thought about doing it in individual parts and then realized I couldn't really show a benefit until I did everything. And it was, yes, it started out as a small Saturday afternoon job, and it got out of control. Yeah.
Yeah, so this new Barrow system for high altitude, this is for flying at like 80, 100,000 feet, and it's actually already implemented. We just need to PR it and get it through. So that's quite worthwhile.
Now, we did get some of the other text changes through.
There's a few more from that glider project that are outside of that PR.
I was thinking about some of those, which were
and
we found a couple of small bugs too.
Yes, I think you should probably have a chat to Samuel at some time about the gliders, because it sounds like he's doing some work in there with integrating some of the data products from text with his glider work, and the bug fixes that you've found for gliders in text could be quite relevant to what he's doing.
Yeah, because
yeah. Hi, Andrew. I'm actually on the call.
Oh, hi, Samuel.
Yeah, hi. Yeah, that would actually be really interesting. Because there's a few, as you said, there's a few text kind of couplings that we're introducing. But also actually for our project, we have a bunch of text tweaks and enhancements for our application. It'll be interesting to see if they are general enough to make it back into upstream.
Yeah,
I can send you a link to the branch. The branch we've done all this stuff on is public. It's just not PR'd yet, and it includes some stuff for high altitude flight that might be relevant to what you guys are doing too.
And the other thing, Samuel, is that the PR where I've got the tighter integration of that horizontal and vertical tracking loops, that actually also rewrites the pitch control loop for text, rearranges the block diagram to move the integrated down the cascade one level, so that we don't have we don't end up with problems with overshoots, when the same problems with overshoots when capturing height changes. So there's been a bit of a change there, but I'm not quite sure how that's going to work with a glider. So
interesting. Yeah, so we're actually in the process at KH Aerospace of kind of switching from our flight branch, which is based on master from I think almost 2 years ago now, to the more to basically 4.1. So as part of that, we need to evaluate the impact of any changes like that. So yeah, definitely good to work together on figuring that out.
Yeah, your GMT time zone.
Yeah, GMT +1 right now, but yeah, UK time.
And you might have to send Paul and me one of your aircraft each. I think it's going to be absolutely essential.
Let's try. Because you don't have enough.
I'll do my best.
Do you?
Yeah, I'll see if I can get that one through. I'll try my best.
Just put it on petty cash.
The required number of airplanes is N+1, and we all know what N is.
Indeed. Yes, I was taught early on, and he who dies with the most toys wins.
Speaking of height control with the text, I'm not sure if this is already a work in progress or if there's a PR for this already, but it'd be interesting to see if there's a way of having the text with more of a look ahead capability in terms of knowing upcoming changes in demanded climb rate or demanded altitude.
Yes.
Because I think right now the text only knows basically the current demanded height, which obviously it can't directly control. It doesn't know, I believe, the current target climb rate and how that's going to change.
I actually do have in that branch, in that PR 15441, there are some changes there to add the capability on the interface to go to a tight tracking mode where you also demand the vertical rate as well. So to try and do that, rather than having text sort of differentiating to get the rate and then filtering it, and you end up with quite a bit of lag.
Right, because so that's one, yeah, because landing is one place where that causes some problems because as you say, there's lag involved. And I think in the landing code, the text actually tries to project ahead to cancel out that lag.
Yeah.
But that then leads to some strange effects, especially when the flare point occurs, because again, the text doesn't really have an idea of how the demanded height is going to change after that event. So there's some kind of discontinuities, which again, we've kind of dealt with in slightly ad hoc ways. And having that look ahead capability might be a nice way to deal with that in a more unified fashion.
Yeah, I mean, unfortunately, it's only looking ahead in the sense that it's taken the current velocity, the climb rate and the height. It's not smart enough to know that you're about to level out.
Right, yeah, and that would kind of require all the sort of mission height handling to be sort of refactored so that you could actually ask, what is the demanded height going to be in, 5 or 10 or 15 seconds?
Yes, well, you could almost have the leash, the concept of that leash that pulls it around, but we do it horizontally with the L1. You could do the same thing vertically in theory.
Yeah, and previous projects I've worked on have actually had both of those concepts combined so that there is only one leash and it's a 3-dimensional leash.
Yes, that's
so it combines those two concepts.
Yeah, that's what I've done with projects that have needed to do very, very tight trajectory tracking. So, and it works extremely well. If you combine that along with an acceleration, a G-demand autopilot, you can get exceptional tracking, sort of half-meter RMS errors relative to your estimate.
Yeah, it'd be great to get to that point. And I think, it's not a fundamental shift. It's just sort of, refactoring a lot of the logic we have currently to be able to pull out a bit more information and a bit more kind of foresight into some of those controllers.
Put Tridge and Sid as the point people for the remote ID, although
it's going to be broader than that.
Yeah,
Jeff's a major part of this.
Yes, Jeff.
And James, and it's going to be quite a few people working on it.
Yeah, I mean, I got asked.
I'll definitely be involved, but it's it's worth having because it's a fairly large lump of work to produce something that's really usable.
I think there will be two components. I think the hardware and the software. From the software perspective, yeah.
I was just thinking, I'm working on the software, but I've got some of the hardware already. Jeff's already pointed me at some of the right hardware to work with. So I've got some of that.
Yeah, we have been working on some hardware as well. I think we have some prototype in the pipeline as well from the CubePilot side. So yeah.
Yep. I'm sure we'll end up with multiple solutions. It's the sort of thing where there won't be a one size fits all, because we'll have everything from the very, very low end hobbyist up to people flying multi-$100,000 vehicles.
That's from a hardware perspective, that's true, and also because of what.
But from the software perspective, I think it's most likely going to be a Perif implementation.
So what kind of implementation?
Depending on the license, I guess.
there's some things still to be worked out there, Sid, in that there is no like approved means of compliance from the FAA on what they're doing yet. So there's a whole bunch of variables there, but basically from the ArduPilot side, I think if we focus on the API to start with, then just kind of nudge it around the edges depending on the specifics of how that means of compliance falls out, noting that some of us kind of have some visibility as to how that's progressing. I think we can be very, very general in the ArduPilot side, and the device itself will be what has to go through that means of compliance, not ArduPilot.
The list is looking pretty good now. Looks quite complete.
Although someone deleted the simulations column.
I did. Sorry. It was empty, so I just figured, well.
Yeah, I was just about to move because Twitch actually has simulation stuff there that I was about to pull across. I was kind of like, where'd the column go?
Sorry. I'll put it back. Actually, I didn't actually delete it. I renamed it. Stole it for another purpose. Okay, here we go. Sorry. Back here.
I'm hoping someone's going to write Hittle in there.
Oh yes, please do put Hittle in there. It's really quite easy now. It's probably like a weekend to get Hittle working quite nicely again, well, maybe a bit longer. There's a bit of stuff breaking out the simulators. We basically need a firmware build target for the Hittle executable that just is basically sim aircraft with a shim around it. And I've already discussed that a bit with Peter. And so that's the main thing, so to break that out so it can run standalone without having a vehicle inside it.
I wonder if we should maybe put the productionization or integration of the ANU vision system on here somewhere.
Yep.
Should I put that under EKF or Copter? I'm not sure. Maybe EKF more than anything else. It's almost not a software development job. It's more of a documentation job. But any opinions?
Well, there probably will be some development needed. There's sort of two parts to it. One is integration of their VIO system, but there's also their EQF, which is, they've got some commonalities in terms of the maths. And one of them would be a completely new, state estimation type, a new EKF type in ArduPilot. And the other would be just the VIO testing and documentation and that sort of thing.
So with the EQF, that would be an EKF that can consume vision.
So EQF is like a new linearization, I guess you call it, Paul, of an EKF, a new way of approaching a state estimation. And the elements of that are being used in their visual odometry system as well. So there's some overlap, but from our point of view, it's sort of two separate systems.
Yes, that's right. Yes. I mean, the first step with supporting them is ensuring that we can get data. I mean, their first requirement is data that's with a consistent timestamp. So, and the next requirement is to make sure that when we get the data back from them, incorporate back into our EKF, that we've got enough buffer length to handle it, and that also that the timestamps are correct. The rest of it, it just sounds, it's no different to another external nav system.
Yeah. Where should we put it? Should we put it into the EKF, or should we make a new other column or docs wiki?
I think EKF should be renamed as maybe nav system or something like that.
EKF and
Charles.
All right. EKF and what? Estimation?
Estimation system. sensor processing.
Has anyone asked about raising the loop rate?
Nobody yet. Not on the list.
Wayne?
So yeah, last time I investigated that, the main bottleneck on that was moving Mavlink processing to its own thread. And so that's something that Peter and I actually had a PR to do that like 18 months, 2 years ago, which is bit rotted. And there's a few difficulties with it, but if we get that done, then the existing infrastructure for higher loop rates will be a lot easier. I don't think we should raise the default loop rate for any of the vehicles, but to be able to more easily support higher loop rates with the breakout of the rate loop. So there's sort of two parts. There's the breakout of the rate loop, and there's the Mavlink separation.
Yeah, well, I think that'd be awesome to be able to do those on a separate thread. I've seen some of the effects we get with the current situation. Yeah. I'm just wondering if we'll be playing whack-a-mole where we then discover that, oh, SRTL has to move. Oh, well, that's already on its own thread, but, you know, we'll find something else, which is, yes. You know, stuff in the main loop every now and then.
Yes. And you're absolutely right. It was surprisingly easy to do that little prototype PR that moved Mavlink's own thread, but dealing with all of the little subtleties could take quite a bit of time. So I wouldn't place it as a high priority right now for me. But yeah, I know that some people would really like to be able to, you know, regularly run, say, 4 kilohertz loop rates.
Something we need to make sure we get done here, I think, is that build server. Now, there is a GSOC project for it, but we have to make sure that goes through to completion.
Yeah, so I'm pretty confident that will go well. Particularly now, GSOC is actually, we originally thought it might be just 1 month. It's actually like 2.5 months of development, which is a much more reasonable time period. And so I'm planning on working closely with the student on that project, and Andy's going to be involved a fair bit as well. So yeah, I'm pretty confident that will happen. But there'll be a whole bunch of stuff within our structure, like our parameter markup, to make more features optional and to add the markup into our code so that this tool knows about the optional feature. And that's not the core tool. That's on all the rest of the team to sort of mark things up as this is an optional feature. Like, for example, I've got to do some work to make quad plane optional in plane. And there's a bunch of restructuring in plane needed to make that possible. And then the markup in the code to say, this is how you turn it on, this is how you turn it off. Because if I just add that one, that will immediately get the 1 meg boards with a whole lot of other features if they're not VTOL, because they'll gain a lot of space when you cut out quad plane.
And if you've got a VTOL, you really should have a decent board in there.
Yeah, some people do run the really low end boards with VTOL, but not as many. And they'll just have to cut something else out. I mean, something has to make room, but it gives a lot more flexibility.
Is this something that should be done ahead of time before the GSOC project?
Not necessarily. The GSOC project only needs 2 or 3 things that are selectable, right? As long as it's a list and as long as it's parsing it as a list of JSON things, then the existing ones that are already selectable is plenty for the project. So I don't think we need to complicate matters.
Which selectable ones are you thinking of? The HAL food?
Well, HAL minimize features is an obvious one, right, but then the turning on and off, like NMEA, turning on and off EK2, EK3 is a fairly obvious one. Turning on and off optimization, like O2.
But we want to be pulling these out of metadata rather than
exactly. We should be. The initial plan that I've discussed with the student who's applied is that we will manually create that metadata for the first time, right? Manually create that JSON file so that it doesn't block the project. And then it's a separate project which the student may well end up doing, right? But it's basically to take a bit like our parameter parser and generate the metadata. But that's a completely separable project, and so it shouldn't block the main project.
And we should look forward to the day where we can kill HAL minimized features in its entirety.
Indeed.
That'd be awesome.
Well, I've just had a look at that today. There's actually very few boards that still have it. And with all the other restructuring we've done, I suspect we may be able to turn it off on those remaining boards. Like I just checked FMU V2, for example, and it's one of the few boards with minimized features turned on, and it's got 42K free on plane. It's got 70K free on copter. With all of the restructuring we've been doing, particularly dropping EK2 out of the build there.
Just a little bit of that up its sleeves.
Yeah. So
cool. All right.
It might be a fairly small thing to kill it.
It'd be good.
It's kind of ironic though, isn't it? Because we've got a different HAL minimized features by proxy now with all the features that we're turning off.
We're using the 1 meg size instead, but that's where the custom build server is going to be so good to be. One difficult part of it that we haven't discussed with the potential student is estimating the flash cost of each feature, because it'd be nice if the tool actually said, this is how much you're going to save approximately by picking this selection. And we don't have the metadata to feed that.
No, we can generate that. It's going to be a slow process.
We can, it'll be slow. We'll have to sort of, have this background task that slowly churns through and builds that metadata.
It'd be like a once a day kind of thing.
Yeah, or even just
a server.
A very low priority task on the build server to slowly churn through stuff on boards and turn it on and off and build up like a big table of what's doable and the cost of the feature.
Something like Bloaty can spit that data out for you, though, surely.
Oh, it's all doable. It's a bunch of compilation to do, and somebody has to write the script and the care and feeding of that to make sure it's robust. So I didn't think that should be part of the core GSOC project, because otherwise the GSOC project just gets, it's got too much to do. So I think it's separable.
Pierre's already started on some of the infrastructure to do that. I think Pierre's already working on.
Yeah, we've got that stuff in CI already, which is one of the pieces of what we need.
Can I just go back to the raising the loop rate question?
Yep.
I as well as Mavlink, I thought one of the issues there was also separating out the EKF processing in the fast loop.
Well, it depends which way you go. I mean,
the output observer can run very quickly. We could split that out. If you really wanted to push the timings and get a bit of latency out, you could run the output observer on a different scheduler to the rest of the EKF.
Yeah, with a semaphore to make sure for the common data structures.
Is that the thing that takes the time then in the fast loop, the output observer? Not that I know what that is, but I'm repeating it.
Sorry, say again?
Is that what takes the time then, the output observer in the fast loop?
Okay, so the EKF, because it has data coming in at different times, it buffers its data and it runs on a delayed time horizon to bring everything together at a common time. And then it's got a separate little complementary filter that then takes the states of the EKF and then propagates them forward using the IMU data by the 100, 200 milliseconds, whatever that time offset is. And that output observer can run you can run it at a kilohertz if you wanted to, because it's very cheap. The main EKF loop runs at 100 hertz. In theory, you could run that output observer and you could move that into a different point onto a different scheduler item.
The other approach is to not run it at all and just use the bias corrected gyro data in the rate loops. I
thought you were talking about the attitude loops. The rate loops.
It depends. That's the big question. Do you want attitude? If you want attitude, you've got to run, some sort of, like the output observer. But if you just want the rates, and if Copter can get away with just having the rates, then potentially we can run none of the EKF and at that very high rate, and just get the most recent bias corrections from the EKF. From the last time it ran, and use that.
So you're thinking of moving that right up to the top of the scheduler table, just
well, no, separate thread. So there's a couple of different ways to do it. One is that the rate loop update is its own thread. right? And so it basically waits on the IMU, and when it gets, and then it runs just the rate PIDs. That would be the fastest architecture, I think, but there's some, gotchas with it. So anyway, it's something that needs a whole call itself, really.
The rule of, in terms of latency, the golden rule is that you synchronize to the primary sensor for your fastest loop, which is rate loops, which means really synchronizing, running those rate loops synchronous to your IMU.
Yeah, that's right. What we need to do then, we still need a metronome for the main thread as well. And what we'd end up is like an event architecture where that rate loop thread goes and sends an event every n times. You'll have like a multiplier, and then it'll say, tell the other one to run when it's idle. But we've got to make sure things like Mavlink still get through. We don't end up starving things that, because situational awareness for the vehicle is quite important. Maybe not so much in racing quads where they just use the OSD, but I mean, the OSD does have to update, for example, at some reasonable rate. We can't just starve it of CPU because the rate loop wants to run at 4 kilohertz.
Yes. And by the way, I think it's also worthwhile having a look at the, well, 6 months ago, I did a audit. I went through the loop structures for quad plane and how we fall through, and was looking at that and realized that there was actually some latency to be taken out of the gyro to control surface for quad planes. So as in when I say quad planes, I mean tail. I was talking about tail setters. And that may be one of the things that makes them a bit tricky to tune. Is I think we've got more latency on our rate feedback loop there than we should for a vehicle that can be a bit unstable.
Okay. Well, I'd love to look at that too. There's probably I'm not at my best at the moment, sort of after 3 days of conferencing late at night. So I don't think this is the right time to dive into that. But another time when we were a bit fresher, I'd love to have a chat about that. And because I'm restructuring quad plane a bit at the moment for this new landing approach PR that I started rebasing at lunchtime. And now that we've got S curves in, so restructuring of quad plane is one of the things on my, front and center right now.
Guys, I've got to go. I'm being summoned. So
no worries. I think we're just about done anyway. Actually, this has been quite good, and I think this project's format in GitHub is really quite good.
Yeah, I think we can spend a little bit of time over the next few weeks or whatever, just pulling in the relevant issues so that we can track them back into the firmware repo as well. But I think it will, it's more accessible and more visible than the GDoc. So I think that's good.
Yeah, I think it's been good.
It's been awesome 2 days. Well done, everyone.
All right, so I might stop sharing my screen and we'll just wrap up the conference. So thank you all for 3 wonderful days. Really enjoyed it. And I'm really looking forward to seeing many of you down here in Canberra next year. So we have a booking. We've already paid for the pizza, so you've got to come. So it'll be fantastic to see a bunch of you down here. Yeah, really, it'd be great to do it. I think we should probably try and have it online as well to be able to have people remotely. There'll probably be some countries still that can't fly. And, or their citizens might be able to fly, but no other country will let them land, is the other possibility. Plus remote, those who just don't, want to travel for whatever reason to the other side of the planet, slackers. It says me, who hasn't traveled overseas for about 6 years.
Good ecological choice not to fly as well, of course.
That's right. That's right.
Save your CO2 budget for something else.
That's right. I expect you to put some water wings on your Tesla and drive it down here, Randy. So submarine Tesla. Anyway, it's been absolutely fantastic. I think we're going to have a great year, and it's the talks have been brilliant. It was really a lot of new stuff coming through. 4.1 is just going to be absolutely fantastic. So it's been a long haul, and thank you to everyone on the dev team who's pulled together to get all the stuff ready. And so you're going to press the button pretty soon on Rover 4.1, Randy?
I've pushed it. It has been pushed.
It. I didn't notice.
Wow.
Oh, it's terrible.
Yep. It went out this morning, just between talks.
Right. Okay.
I noticed.
Fantastic. Congratulations.
Yeah.
So I copter soon, and then Plane will be chasing you.
And then I'll wait for the UKF bug reports to come in.
Yep.
Yep. And all the Esp bug reports we just pipe straight to Leonard. And you know, it's you're muted, Leonard, by the way.
S curves, there won't be any bug reports.
Of course not. No,
there are no bugs.
Not at all. Yeah.
Just undocumented features.
That's right.
Yep.
That's right.
Brilliant. So thank you, everyone, and look forward to talking to you in the upcoming dev calls, weekly dev calls, and see you all down here next year.
Cool, guys.
Catch you guys later.
That's great.
Thanks, everybody.
Thanks, guys.
Right. Bye.
Yeah.
Thanks.
Bye.
Thanks. Yeah.
Nice to see you guys.
Catch you later.
Ciao, Bruno.
Tchau, tchau, Luiz.